Hi, good morning, everyone. Welcome to the first class of statistics. Today's class is going to be very, I can say theoretical, but an essential one. We want to understand the different aspects of statistics before we can go ahead and do, I can say the numerical aspects like probability or other things, right? The first thing that we want to do today is to get an overview of what statistics is all about. So you can go ahead and write the name of this as overview and descriptive stats. The aim is to understand what stat does and what are the various chains of statistics, what are the various branches of statistics. ठीक है जी? So बेटा शुरुआत कैसे करेंगे हम? To begin with, let us try and understand what is statistics. सबसे important जानना ये है कि stats होता क्या है. So see, whenever we work in the real life, we have a lot of data available to us. Just take an example. I am going ahead and I am, working on Facebook. Okay? You are also doing Facebook. Third person is also doing Facebook. When many people, they go ahead and they, look through Facebook, data is collected. What data? That which kind of ads you are watching on Facebook, which kind of ads I am watching on Facebook, right? Similarly, data is collected when you go ahead and you watch YouTube, for example. Okay. The ads that would be displayed to you will be very different from the ads that will be displayed to me. Why will that happen? That will happen because in the background, this Facebook or this YouTube has gone ahead and they have collected information. They've collected data and they've understood, they've summarized that data and they've gotten on some insights that this kind of person actually likes watching this video. So the ad should be shown correspondingly. Like for example, I will see a lot of ads related to data science courses on my YouTube because I am one person who keeps watching out for data science videos. So the aim is that in today's world, we have immense amount of data, but we want to go ahead and we want to organize and summarize that data. And not only that, we also want to go ahead and draw some conclusions from those data sets. That is exactly where statistics is useful. That is exactly what statistics is doing for you, right? So what is statistics? How can we define stats better? We can say that stats provides methods for organizing and summarizing data and for drawing conclusions based on that data and for drawing conclusions based on the information contained in the data. Okay, beta. So I want to go ahead and I want to find out some information from the data set, and that is where statistics will be useful for me. Now let's take some examples for it. So for example, let me write down example 1 for you. So let's say that I want to go ahead and I want to provide insights of the data. Provide insights on data माने क्या? Just for example, I am one person who wants to go ahead and go through the stock market a lot. ठीक है? I want to understand कि which share is on a hike and which share is on a decline. How can I find those insights? Statistics will help me. I can find out that from the last 7 days, what has been the average market value of this share? I can find out a trend that has this been on an increasing trend or a decreasing trend, right? So whenever I want to find any kind of insights on the data set, statistics will be useful to me. So just take an example. For example, the CUET result just came, right? I want to understand how my students performed. What was the average score of the students, right? How many students were able to get admission in Delhi University, right? So whenever we have to go ahead and we have to get some insights from the data set, that is where stats will be useful. Now, another thing which is important here is that this statistics can only be used in case of uncertainty and variation. Let me explain to you why. Imagine that you are certain about an outcome. You know for sure that whatever students I have, everybody will get into DSC. Then there is, or into Delhi University. Then there is no analysis involved. The analysis comes into picture because of the uncertainty, because there is some variation in my data, right? Because I know that out of 200, maybe 120 would have gotten into Delhi University. That is where the analysis comes into picture. So stats can only be useful whenever there is uncertainty and variation in your data set. If there is no uncertainty, if you're certain about the outcome, then there is no role of statistics, right? So for example, one of the very important tool of statistics, that is probability, right? And probability can come into picture only when there is uncertainty. So if you remember, a lot of times I give this example that, take the example that it will rain and it will not rain, and if it rains, you will not be able to organize your event, right? So there is uncertainty, and because there is uncertainty in the picture, that is the reason why I am able to introduce a component of statistics, which is probability, right? So the point is that an important aspect of statistics therefore becomes uncertainty and variation. Okay, another example can be how your market performs, how cricket players will play. So we have a whole chain emerging now, and that is called sports analytics. Sports analytics tries to find out when the player will be injured, how many runs the player will make. But again, all that is possible because there is uncertainty in your data set, right? So because there is uncertainty, that is why we have the role of stats coming into picture. Now, we want to go ahead and understand some important terms today. So the first important term I want to talk about is population versus sample. Okay, beta. So beta, what is population? When you go ahead and you collect data of all the people possible, take it, just say for example, if I go ahead and I know that there were 1,10,480 people who gave the CUET exam, and I go ahead and I collect the marks of all these people, then this is my population. So what is population? Population means all people together, right? For example, voting में population is very useful. I want to understand the vote of all possible Indians. That is what I will do at the end, right? So that is population. Now, when you have information available for the entire population, beta, that is called as census. So please write down. We have something which is known as census. Census means I am able to collect desired information about all possible data points of population. Let me give you an example. Suppose every 10 years, India wants to understand how much its population has increased, what has been the salary of the people, income of the people, how many people are below poverty line, etc. How many members are there in the family. But I am doing something which is called as census. I am collecting information about every possible person who is there in India. बहुत मुश्किल है. I can only do it once in 10 years. बहुत costly affair है. So when you go ahead and you collect information about every possible person, that means you're collecting information of the population. That is the census. But due to many constraints, time, money, other resources, census is impractical every time, right? You cannot take information about the entire population. Okay, beta. Therefore, what comes into picture is called as a sample. So a sample is a subset of the population. And why is sample used? Because it is impossible for me to collect the data from the population. So we can say that due to time, money, and other resource constraints, we go with sample. And what is sample beta? It is a subset of population. So I want to go with a subset. पूरे population की जगह थोड़े से part के साथ जाना चाहेंगे, and that is called sample. Take an example. Suppose you would have heard that every this news channels, after you have done the election, पूरा process voting का पूरा हो जाता है, they go ahead and they come up and they tell us, according to us, this year so and so party will win. But how do they know that which party will win? They have not collected information from each and every person. They have only collected information from the samples. So what will they do? They will go outside voting booth and they will try and collect information that which person voted for which party. And on that basis, they will come up and say that according to us, currently we think that this party is going to win. That information may or may not be true. कभी-कभी उल्टा भी हो जाता है. They may have said that this party will win and some other wins. क्यों? क्योंकि उन्होंने जो भी information collect की, वो sample पे की है, और जो actual में answer आता है बाद में कि which party is winning, वो population पे आता है, right? So sample is a subset of population. Because of constraints on time, money, effort, other resources, people go with sample. So whenever, even if you go for PhD sometime in your life, you will know that you will only be working with a sample. The next definition that I want to go through today is called a variable. So beta, what is a variable? Any characteristic whose value changes from one object to another is called a variable. For example, I have say 10 students in my class. Student number 1, student number 2, till student number 10. And I go ahead and I ask, beta, how much did you score in your microeconomics paper? This marks will vary from student to student. One must have scored 40, 42, 38, and so on. They have scored different marks. So marks is changing from one person to another. That means this is a variable. In particular, this is a numeric variable. This is a number that is changing from one person to another, right? Similarly, I may ask, what is your gender? And people may tell me male, female, female, male, and so on. Again, this is changing from one person to another. It has 2 or more values attached to it. So beta, this is also a variable. But now this is a categorical variable because it is having qualitative values. And this is having quantitative values. Clear, beta? So what we can say? We can say that any characteristic whose value changes from one object to another that is called a variable. Variable can be qualitative or quantitative. Now, when you collect data, data can have either single or multiple variables. Just for example, I am only interested in understanding the proportion of male and female in my class. So I will only collect one data point, the gender of the people. So when I just go ahead and I collect a single variable, but that is called a univariate data set. So a univariate data set is one with a single variable. Like in my class, I am just understanding the gender of the people. So I may collect 10 students ka data point male, female, female, male, male, female, and so on. I am collecting only one data point, so it is univariate. The other thing that you have, that is beta multivariate. The moment you collect more than one variable, that becomes multivariate. Like for example, I am interested in understanding marks and gender and let's say your family members, number of family members, etc. I am interested in understanding a lot of different information about you, about my different students, right? Then beta, that becomes a multivariate data set. Now, a special case of multivariate data set, that is called bivariate data set. So beta, bivariate data kya ho gaya? Any data which has exactly two variables. Like for example, this one. I wanted to understand your marks and gender. दो ही चीजें जाननी थी ना. If I collect only information about two variables, then that is called a bivariate data set. So when I collect information about exactly two variables, and you can say that this is a special case of multivariate. Okay, beta. Now, we want to go ahead and understand the branches of statistics. ये बहुत important है. I can divide my entire stats in two main parts. The first one is called descriptive and second is called inferential. First, understand descriptive statistics. When you go ahead and you just want to present and collect your data, you want to describe your data. Ki, acha, what is the average marks scored by students? Or, what is the correlation between your marks and correlation between your marks and let's say your family income. ठीक है, ये बहुत important study एक econometrics में होती है बाद में. Or I want to just go ahead and understand that okay, who has scored the highest marks? That means what is the mode? So when you want to go ahead and you want to describe your data set, right? That is descriptive statistics. So descriptive statistics basically is presentation and collection. Ulta likhna chahiye, collection and presentation kar dena of data. You first collect the data, then you present the data with some descriptions. Like on an average, the marks is this. The highest mark scored is this. This many people have scored this many marks. So when you go ahead and you collect and present data, that is descriptive statistics. This includes making some diagrams also, like drawing histograms, right? Or finding out mean, median, etc. This is all part of descriptive. Now, when you go ahead and you draw conclusions from your data set, that is inferential statistics. देखो यहाँ पे inferential में एक term आ रहा है infer. और infer का मतलब होता है to draw conclusions. So when you go ahead and you draw conclusions from your data, like, अच्छा, इसमें जो use होगा, I will teach you that later, which is called hypothesis testing. But just for now, let's say I'm taking an example that 50% of the males have higher wage than female. I am drawing an inference. मैंने एक data set देखा और उस data set से मैंने एक inference draw की कि मेरे data set के हिसाब से ये चीज true है, ऐसा हो रहा है. So when you go ahead and you draw an inference, you draw a conclusion from your data set, that is called as inferential statistics. But for descriptive statistics, when you draw these histograms, mean, median, ये सब करते हो, we have many statistical tools present. Few of these tools are R, Python, Stata, etc. So these are some of the statistical tools that are present that help you to do this descriptive statistics. Now, I want to draw a quick diagram here, and then I will explain you what this means. So imagine I have population here. And imagine I have sample here. बेटा population से sample जाने के लिए you will use probability. Probability माने कि when you go from population to sample, you will use probabilistic reasonings. ठीक है, जैसे for example, let's talk about that I have the data of 100 car drivers. And I want to ask कि बेटा कितने कार ड्राइवर्स होंगे जो रेगुलरली अपनी बेल्ट पहन के ड्राइव करते हैं, right? So when you go ahead and you want to check some information like this, like how many car drivers are wearing lap belt regularly. So beta, you will describe your data set. Like for example, आप एक average निकालोगे, आप कोई diagram बना के देख सकते हो. You will go ahead and you will try to describe your data sets in many ways, right? And to collect this 100 car drivers, शायद रोड पे चलते हुए आपको 1000 गाड़ियां दिखेंगी. You will see thousands and thousands of cars. Out of those thousands and thousands of cars, you will apply some technique to get these 100 drivers. Maybe probability. एक को पिक करने की कोई प्रोबेबिलिटी रही होगी कि अच्छा ये 4 कार्स गई, इसमें से मैंने इस एक को पिक कर दिया, है ना. सो यू विल रैंडमली पिक. अच्छा, to pick up sample is also a technique. I will talk about that in some time. But abhi ke liye, out of the entire population, you will pick up some car drivers and then you will do deductive reasoning on it. कि on an average कितने car drivers हैं जिन्होंने car belt पहनी, who wore car belt, right? That is called deductive reasoning. You are deducing something. So this part, this is called deductive reasoning. So deductive reasoning क्या हो गई? When I make a statement, what kind of statement can I make? I can make a statement and say that beta, out of 100 car drivers, 65 wore seat belt. तो मैंने जो अपना सैंपल कलेक्ट किया ना, उसमें से मैंने आपको एक इंफॉर्मेशन निकाल के दी कि 65 सीट बेल्ट पहनते हैं. अब once this deductive reasoning is done in the sample, you have got this information, you want to go ahead and you want to do inference कि इससे मैं क्या conclude करूं. So then you want to go back and you want to do inferential statistics. बेटा inferential statistics को समझने की कोशिश करो. Inferential statistics ये बोलती है कि अच्छा मेरे को अपने सैंपल के बारे में तो एक इंफॉर्मेशन मिल गई है. I know about my sample that 65 out of 100 people wear seat belt. What can I conclude about the population? इसके बेसिस में मैं क्या बोल सकती हूँ कि मेरी पॉपुलेशन में कितने लोगों ने पहनी होगी. So when you want to go from sample back to population, you will use inferential statistics. So what will inferential statistics ask? Okay, in your sample, out of 100 car drivers, 65 were wearing seat belt. Then can you conclude that in your population, say more than 50% drivers wear seat belt? So beta, what am I trying to do? I am trying to go from sample. जो भी मुझे sample से information मिली है, उसके basis पे I want to conclude something about the population. यही तो voting में भी मैंने आपको समझाया. That some people, I have collected information about some people and they have told me that they voted for party X, party Y, party Z. They voted for different parties. Based on what these people have told me, I want to conclude something about the population. That in the population, how many percentage of people voted for whom? This is called inferential statistics. You are trying to infer something about population based on sample. Okay, beta. To do this, we use a very important tool which is called hypothesis testing. And I will be spending a lot of my lectures around this hypothesis testing also. ये भी हम full-fledged करेंगे बाद में. अभी के लिए we want to understand different things. Now, there is another thing that you should understand, and that is enumerative versus analytical statistics. All these can come in MCQs beta, so you should be sure about these things. Try and understand. And enumerative statistics is done on the universe actually studied. Right? It describes the existing situation. But an analytical statistic, as the word is suggesting, an analytical statistics that is done to evaluate the future. थोड़ा समझने की कोशिश करते हैं through an example. Before we do that example, beta, I want to tell you that we have already studied what is a population. That's the whole data. And what is a sample? That's a subset of the population. Between population and sample, some books like DeVore, they use a term called frame. अब ये frame क्या चीज है भला? Frame is basically accessible data. So population है whole data set. जैसे इंडिया का whole data मतलब कि जितने भी लोग हैं मुझे उन सब का इनकम जानना है. I want to know income of all people. But beta, I cannot know the income of people who are doing black market, right? Who are in illegal activities. उनकी इनकम जानने का कोई तरीका नहीं है. So my accessible data will be only people with white income, right? And from that accessible data, I will create a subset. मैं सिर्फ कुछ लोगों की ही, जो भी लोगों की white income है, शायद मैं उससे कुछ लोगों की income निकाल के देखूं. So out of accessible data, you have the data that you want to work with. Okay. So basically from population to sample, these books, they include another term called frame. Frame refers to accessible data set. So you go from population towards frame, and jitna bhi accessible data set hota hai, from that you go to the sample. Now, let's go back to enumerative and analytical study. So enumerative कहता है that I want to work with actual information and I want to deal with existing situation. Just for example, I may go to a firm, right? And I may ask different people about their feedback. That beta, okay, I ask first person, what is your feedback for this firm? Second person, what is your feedback for this firm, and so on. This is describing the actual situation in the firm. कि अच्छा इस टाइम पे इस फर्म में इतने लोग satisfied है और इतने लोग satisfied नहीं है. ठीक है? So based on that, I will take some action on the population कि जो लोग satisfied नहीं है वो कितने लोग हैं, right? So enumerative basically works with the actual data set and it takes action on the population. It takes action on population. Now, let us compare enumerative with analytical. Analytical क्या करता है? It works with the future. ठीक है? जैसे for example, I know that my organization, people are satisfied with me. Now I'm thinking about the future. That in future, I want to go ahead and I want to stop work from home for my employees. Then what will I do? I can do something like this. My entire employees, I can divide them in two parts. Group 1 and group 2. For group 1, I will give them work from home facility. And for group 2, I will not give them work from home. And then I will aim to see which is more efficient. And accordingly, I will bring in my future policies. So this is a process that I am doing, right? When you are involved in existing process and you want to do something in the future, मेरा future का aim है to change my policy, whether I should be launching this or not. So when I want to work with the future, right? And to work with that future, I go ahead and I bring in a process that is called analytical study. So aim of analytical study is to go ahead and create a new system based on a process. It is for the future. The aim of enumerative study is to focus on today's results, is to focus on the actual situation, not on the future. This is my actual situation. How many people are satisfied with me? How many people are not satisfied with me? This is my actual situation. That is enumerative. But when I go ahead and I want to deal with the future situation, that is called as your analytical. So please write down one line each on this beta. So write down enumerative study is a statistical judgment in which focus is on the present results. Okay. It is on what is the existing situation. So you can say it focuses on existing situation. But let's compare this with analytical study. So analytical study, it is focusing on the improvement of the process involved. Improvement of process. It is focusing on future situations, right? So it will focus on creating results in the future. Now, let us go ahead and talk about collection of the data set. Data can be collected in various methods, various sampling techniques. But for now, today, I just want to focus on few of the important techniques that are given in any statistical books. Okay. So the first technique that you have is called simple random sampling. Beta, what is simple random sampling? The word, focus on the word. Random sampling. I am randomly creating samples. In this, what you do is, take an example. Just for example, I have a population of 1,000 students. And I want to go ahead and I want to create a sample of 100 students. What will I do? I can go ahead and I can give number to each student. So I can say, okay, this is number 1, number 2, number 3. I have allotted number to each of them. And now what I can do is I can just go ahead, I can start a lottery system. So I will put all these numbers in a box, 1, 2, 3, and so on. And then I will go ahead and I will pick up 100 chits from this box. So suppose the first chit that comes is number 5. Okay, select that person. The second chit that comes is number 8. Select that person. So whatever number will come in your chit, you will go ahead and you will select that person. And you will do this 100 times. So that 100 people are selected, right? So when we come to the simple random sampling, as the word suggests, you just have to go ahead and you have to randomly select. But random karne ke liye, how do you randomize? To randomize, you can go ahead and you can do this chit method. There is another thing which you can do. Okay, beta. The definition of analytical study. This is the definition. It focuses on improvement of the process. Let me know once you have written. Done. Fine. Now just think about it. So beta, when we talk about simple random sampling. I'm just going ahead and collecting the data randomly. Now here, there is something which is known as random number generator table. Just Google it once, you will get this table. इसमें क्या होता है ना, randomly they will give you some numbers, 4, 2085, 45, ऐसे कुछ random numbers होंगे. You want 100, just keep picking from here. So I will pick number 4. I just want 100, but I want out of 1000. So 1000 में 2085 तो exist नहीं करेगा. Then pick up 45, then pick up next and so on. So you just pick up these numbers which are given in this random generator table, and in that you have done random picking, right? Now, because you are randomly picking up the samples, this is an ideal example of what is called as probability sampling. So I can divide my sampling in two parts. One is called probability sampling, and the other is called non-probability sampling. Probability sampling means it is by the basis of probability. That means by random selection. And non-probability sampling means it is based on your convenience or non-random selection. Right? Just for example, ये बहुत easy होता है. So a lot of times, when I was involved with my students in this research work, and I would ask them to go ahead and collect the data, they would just go ahead and create a Google form and spread it among their own relatives. But when you spread it within your own relatives, then it is a non-probability sampling. You are doing it on the basis of your convenience, right? You are not going ahead and you are not creating any probability per se, right? Probability तब होगी जब बहुत लोग होंगे. So when you go ahead and you get the analysis that 50% of the people watch TV or 60% have TV at their home, and you're just collecting it from your own relative, that is clearly a non-probability sampling. So within this probability sampling, where you're collecting randomly, there the first method that you have, that is called as simple random sampling. और ये simple random sampling है जो हमने अभी पढ़ा कि just number people and एक lottery system से randomly draw people. That is simple random sampling. The second sampling that you have, beta, that is called as systematic sampling. Systematic sampling. ठीक है? Systematic sampling क्या बोलते हैं? It is similar to simple random sampling, but it is usually slightly easier to conduct. ठीक है? Every member of the population is listed with a number, but instead of randomly going ahead and generating numbers, you choose them at regular intervals. Let me give you an example. जैसे I go to a village, and यहाँ पे ना in village के house numbers लिखे हुए हैं. House number 101, 102, 103, 104, and so on. And I go ahead and I say कि ये बहुत सारे घर है, maybe there are 1000 houses, and I want to collect 100 houses. Systematic मतलब अभी भी random ही है, क्योंकि मुझे नहीं पता किस घर में कौन है. But I am systematically collecting the sample. So I collect house number 101. Then I leave 2 houses. Then I collect house number 104. Then I leave 2 houses. Then I collect house number 10567 and so on. So I am following a system. That means I am collecting at regular interval, but it is still random in nature because I don't know which house has which person in it. So here the sample is collected at regular intervals. ठीक है बेटा? Now, a lot of times HRs will use this. Okay? They will just alphabetically put people in their organization, and then they will pick up the first person, then 10th, then 20th, and so on. The third type of sampling, that is called stratified sampling. Stratified, in systematic sampling, AP or GP can be used. Yes, beta, you can use AP, you can use GP, you can use any technique as long as you follow that technique thoroughly. So कुछ भी create कर लो, ठीक है? जैसे for example, I can just say that I will pick every odd person. That's also a way that I have created. ठीक है? You just have to create a system here. Now let's talk about stratified sampling. So stratified comes from the word called as strata. Okay. And strata means, in a way, actually it comes from spectra. It comes from different groups. This is, for example, just think about it. Let's say the government wants to go ahead and it wants to understand how its policies are working. Okay. And the policy that the government created is education for all. Now the government goes to all people who are above poverty line, who are able to afford their own education, and ask them, how do you feel about my policy? It will be a biased result. Of course, they have got nothing to do with the policy. They will be indifferent. They will simply say, okay, fine, it's a good policy. Unless you don't go to the right people, you will not be able to make the right conclusions. So when I talk about stratified sampling, I want that whenever I go ahead and I create my conclusions, it should be representative of all the sectors of the population. Just for example, I should be able to represent all the genders, all the race, all the religions. So I can create strata on the basis of any of these. So I can create categories that, okay, there are some people representing the first strata, first religion, some people representing the second religion, some people representing the third religion, so that I have information from all religions. Okay. So what you do, अभी भी मैं randomly pick करूंगी हर religion के अंदर से लोगों को, but पहले मैं religion के basis पे लोगों को divide करूंगी ताकि हर religion मेरे sample के अंदर represent हो पाए. So I have a population. First, this population will be divided into subgroup. This subgroup is called as strata, right? This can be based on any characteristic. जैसे वो characteristic gender, identity, age, income bracket, religion, region, job role, किसी भी basis पे मैं ये stratas create कर रही हूँ. And then each strata से I will randomly pick people. So randomness is still involved, but now I have ensured that my population has each strata being represented. This is very important in gender bias studies. Just for example, let's say I have 800 males in the organization and only 200 females. Now I want to ask, how do you feel about equality? I pick up 100 people randomly जैसे. तो बेटा अगर मैं डायरेक्टली 100 रैंडमली पिक करूंगी, बहुत हाई चांस है कि इस 100 में शायद 80% मेल ही आएंगे, क्योंकि आउट ऑफ 1000 चिट्स दैट आई विल क्रिएट 800 तो मेल्स की हैं. सो व्हेन आई पिक अप चिट्स, देयर विल बी ऑलमोस्ट 80% मेल्स इन माय सैंपल आल्सो. मेल्स में से दैट दे फील जेंडर इक्वालिटी, व्हेन फीमेल्स में से दे डोंट, और वाइस वर्सा, वी डोंट नो, राइट? सो आई वांट दैट even sample, both should be represented well. So what will I do? I will create strata. And I will say, okay, 50% of my sample should be from males. अब randomly कोई भी male pick कर लो इनमें से, and 50% from females. Randomly कोई भी female pick कर लो. So what I am doing here is that I am representing the strata first and then I am randomly selecting. The fourth one and the last one that I have, that is called as cluster sampling. But a cluster sampling is also very similar. Most students get confused between cluster and strata. So cluster sampling also divides population in subgroup. But each subgroup should have similar characteristics to the whole sample. That means instead of sampling individual from each subgroup, you are randomly selecting the entire subgroup only. Let me give you an example. Just say, let's say, so एक बारी पहले लिख लो, you are randomly selecting subgroup itself. Now let me give you an example. Just say, for example, a company has, let's say, 10 offices across cities. Okay. Or let's say, let's not make 10 offices. Let's say it has offices across 10 cities. Okay. हर ऑफिस में roughly same number of employees हैं. Now, you don't have the capability to travel to each of the office to collect your data. So what will you do? You will go ahead and you will randomly select any 3 offices and you will collect data from these offices. ठीक है. तो अब मैंने क्लस्टर क्रिएट किया है. मेरा क्लस्टर क्या है? ऑफिस. ऑफिस 1 के जितने एम्प्लॉयज हैं वो ऑटोमेटिकली क्लस्टर 1 बन गए. ऑफिस 2 के जितने एम्प्लॉयज हैं वो ऑटोमेटिकली क्लस्टर 2 बन गए. ये सिटी 1 में है, ये सिटी 2 में है, ये सिटी 3 में है. और अब इन 10 क्लस्टर्स में से मैं रैंडमली 3 क्लस्टर्स को पिक कर रही हूं. सो आई पिक अप क्लस्टर 1, cluster maybe 10, cluster 5. I randomly pick up 3 clusters. So here I am randomizing on the cluster itself. पूरे का पूरा ऑफिस मेरा एक क्लस्टर था. मैंने पूरा का पूरा एक रैंडम ऑफिस उठाया. यहाँ पे I was not doing that. Here I was creating 2 stratas और उनके अंदर से मैं लोगों को रैंडमली पिक कर रही थी. यहाँ पे I am not randomly picking up people from office. No. I am randomly picking up office itself. So I'm saying कि ये सब ऑफिसेज बहुत सिमिलर हैं क्योंकि ये सारे मेरे ही ऑफिसेज हैं. इनमें मैंने एकदम सेम तरीके के लोग रखे हैं, सेम जॉब प्रोफाइल के. सारे ऑफिसेज में भी मार्केटिंग के ऑफिसेज हैं. नाउ आई वांट टू सी हाउ दीज ऑफिसेज आर वर्किंग. सो आई पिक अप एनी 3 रैंडम ऑफिस. सो क्लस्टरिंग सैम्पलिंग randomly picks up a cluster, but strata sampling first creates strata and randomly picks up people from that strata. I hope you are able to understand the difference between the two. Okay, so this is very important from exam point of view to understand all 4 types of clustering in probabilistic clustering. Now, I'll stop here for today. In the next class, I will start with non-probability sampling. And then we will start with how to visually show different kinds of samplings. Yes, beta. So I will have these classes every weekend from 12 o'clock to 1 o'clock. I will see, maybe if time requires, we will also extend this to 1:30. But to begin with, we will have it from 12 to 1 every weekend, every Saturday and every Sunday. Right? So the aim is to pick up on these subjects and do them with you quickly, because if you wait for microeconomics to end, it will take a lot of time. So you have to start with me on statistics also. This is what I usually do with my batches during the first week of September, just that I'm starting it 2 weeks early this time. For intermediate videos, you can, yes beta, you can begin seeing videos on the descriptive statistics part. Yes beta, if you take whole group as gender and अगर मेल और फीमेल में से कोई एक ही चूज करते तो वो क्लस्टरिंग सैम्पलिंग हो जाती. बट मेल और फीमेल के अगर अंदर से हम कुछ लोग चूज कर रहे हैं, देन दैट इज स्ट्रैटिफाइड. the books that you have received, beta, that are for your intermediate lectures, and ideally, you, as I have always told you, you have to still do your video lectures. The books are only going to help you with additional material here and there. So for example, I will not just either, I will not tell you who coined the term statistics or who coined the term set theory. That will be there in the book, and it will be useful when you sit for your CUET exam. Please do the books for CUET especially, beta. और किसी के लिए करो ना करो, but CUET के लिए, GATE के लिए, then you have your MSc, then Gokhale. ये जो theoretical papers है ना, उसमें book is very useful. Very recently, GATE has also started giving questions on who gave what term. So it is important that you do books for GATE also. So book for statistics, DeVore is a very good book. But what I will do personally is for every concept that we do, just when I will do with you density functions, for each concept I will give you 8 to 10 deferred example, जिसमें सब कुछ cover होगा. So you should be doing those examples thoroughly. The assignments I give you thoroughly, and then you can either look for, either you can do DeVore or you can do bits and pieces of examples from your SC Chand book. ठीक है? So DeVore या SC Chand दोनों में से कोई भी एक follow कर लो, plus follow all the video lectures thoroughly. Okay. Okay, so we will meet tomorrow. This week will be theoretical. I still have to do some more theory with you. Only then I will go forward with the numerical aspect of stats. Hi, good afternoon, everyone. Beta, today we are going to go ahead and study further on what are the different sampling methods. If you can see, yesterday, we had gone ahead and done some of the sampling techniques of probability type, right? So today I'm going to go ahead and begin with the non-probability aspect of sampling. So what did I say? What is non-probability aspect? Non-probability aspect basically says that you go ahead and you do things at your convenience, right? So basically what it is doing ahead and saying is that you do not go ahead and don't choose randomly. You follow non-randomness. So we want to understand what those non-random types can be. So please write down today's title, non-probability sampling. Yes, beta. So cluster sampling mein, we were saying that we are going to randomize the clusters. Iska kya matlab hai randomizing the clusters? It means that I am not randomly choosing individuals. I am randomly choosing a group. So imagine this. Suppose in your, let's say in your college, economic honor students, there are, let's say, 5 sections. All these 5 sections are alike. It's just that you have 5 sections because, the teacher ratio has to be maintained. All these students have scored the same marks, cut off same से admission हुआ है, so they're very similar in nature. इनको जो subjects offer हो रहे हैं वो भी same है. Everything is the same. So I have section A, B, C, D, and E. Now I want to study how these students are performing, right? And whether they are happy with the teaching methods or not. But I find it very difficult to go ahead and to, ask all these 5 sections, every student, how their performance has been and whether they're happy with teaching or not. So what I do is, out of these 5 sections, I randomly pick 2 sections, randomly. That is cluster sampling. So each section is a cluster. They have similar properties, that they have the same kind of students. But because dealing with entire population is difficult, dealing with all students of all 5 sections is difficult, I go ahead and I choose any 2 clusters randomly and I talk to them. That is cluster sampling. You are randomly choosing 2 clusters. Is that clear now? Should I move on to non-probability now? Okay. So we choose all students of 2 sections. Yes, you're right. Here, randomization is on the cluster, not on the students. Correct. Okay. So now I will go ahead and I will start with the second lecture, and that is going to be non-probability sampling. And in this, the first one that I'm going to go ahead and take will be convenience sampling. सबसे easy word ही suggest कर रहा है what it is. So when I talk about convenience sampling, what does it mean? Convenience means you are choosing at your convenience. Mane, like for example, I gave you an example yesterday also. When I want to do a research and I directly go to my relatives and I ask them, please fill this Google form for me, and I just use that to do the analysis, it is at my convenience. Or let's say that, I want to understand the behavior of people shopping, right? I go to my nearest mall and I just go ahead and from there, I look at the behavior, right? I just ask people to fill the form. Then I'm just going to my nearest mall now. I am not going to any other mall. I am not going to any other place. So when you go ahead and when you have taken your convenience in doing the sampling, you have considered your ease in carrying out the sampling, that is called convenience sampling. Why is it called convenience? Because the researcher is considering his or her ease while getting in touch with the subjects, right? So we can go ahead and say that this is at the ease of the researcher, right? And he gets in touch with the subjects at his convenience. And you can just quote an example like going to the mall. I have seen many people doing this. Many of my contacts on LinkedIn, they just post their Google form on LinkedIn and ask people to fill it. But that is at convenience, right? So convenience sampling is done at your ease. Now the second one is called judgmental sampling, and it is also known as purposive sampling. When I talk about, देखो, word से ही हमेशा याद रखनी है चीजें. So judgmental comes from the word judgment. Purposive comes from the word purpose. मतलब क्या? मतलब you are going ahead and you are doing sampling at your discretion. जैसे for example, let's say that I want to understand how how many people out of economic honors will go for a master's degree and how many people will go for a job. I am interested in only those students who want to go for a master's degree. What will I do? I will go ahead and I will put one basic question first, that are you interested in studying masters? बस इतना question पूछ लो. People who say no, automatically I will eliminate them from my sample. क्योंकि मेरे को उनको पढ़ना ही नहीं है. I am only interested in understanding the behavior of people who want to go ahead and who want to do masters. Otherwise, I'm not interested. So this itself becomes judgment. This itself becomes my purpose. My purpose is to look for people who want to do masters. So I eliminate the people who don't want to do masters out of my sample, right? So we can say that in this case, you are forming the sample at your discretion. Same, just I want to study how people survive who are below the poverty line. So I asked the income level of people. Now, people whose income is below poverty line, I will keep them. But whose income is above poverty line, I will eliminate them. That will not be part of my sample. So when I have a purpose in mind and I create a sample according to the purpose, that is called purposive sampling. Now come to the third one, beta. So this is snowball sampling. Okay, now snowball sampling is basically when your subjects are difficult to trace. Take an example. Suppose, let's take the previous example only first. Let's say I wanted to study people who are below poverty line. Now, there may be people who do not want to go ahead and disclose their income. So even though they will be below poverty line, but because they did not disclose their income, I will be having only a sample of people who disclosed their income. Okay. So which means that my subjects are difficult to trace. My sample will own, यहाँ पे randomization नहीं हो पा रही, because जो लोग बता ही नहीं रहे कि उनकी salary कितनी है, उनको मैं अपने sample में randomly include नहीं कर पा रही. I am not able to include them in my sample. So when I talk about snowball sampling, it is when your subjects are difficult to trace. Let us take one more example. Let's say research on HIV/AIDS. Not all people who have this will tell whether they have this disease or not, right? I will have some volunteers telling that, you know, these are the symptoms, this is how it happens, etc. Right? So only people who volunteer to be part of my research can be included in the sample, because not all people are part of my sample. Only volunteers are part of my sample. Automatically randomization cannot take place, and therefore it is called snowball sampling. So you can keep writing some examples here, beta. So this can be when people don't disclose their income. So only volunteers are part of sample. Now come to the last one, fourth one. This is called as quota sampling. Now, many students in exam, they will get confused between quota sampling and between cluster and stratified. ये तीनों बहुत similar लगते हैं. तो पहले तो you should be very clear that quota sampling is non-probabilistic. मतलब किसी तरीके से मैं randomization नहीं कर रही हूँ. Whereas stratified and cluster are probabilistic, which means I was doing randomization in some way. Now just think about it. Quota sampling is when you have some group in mind. मतलब एक strata type ही बना रहे हो, एक group के साथ ही deal कर रहे हो, but you're not randomizing, right? So for example, I have a group in mind that I want to understand how many people between the age of 15 to 20 smoke. So I have a particular group that I want to deal with, and that is the age group of 15 to 20 plus they should be smoking. I have a quota in mind. Quota means I have a particular group in mind and I just want to take sample of those group, only those people, right? So when you do sampling on preset standard, that means you do sampling only on what you have in mind. Like for example, 15 to 20 age group of people who smoke. I have a particular subgroup in mind now, then that becomes quota sampling. Again, I am not doing randomization here. That is why it is non-probabilistic in nature. So I hope this is clear to you. This can come as MCQ questions very well, beta. You should be aware of probabilistic and non-probabilistic sampling methods. And उसके अंदर चारों methods जानने बहुत ही जरूरी है. Now, today, I want to talk about an important topic, and that is pictorial and tabular methods. Pictorial and tabular methods. But before I do that, let us keep some symbols into mind. So, beta, first symbol. The sample size is denoted by n. So, whenever you collect a sample, that sample size is denoted by n. Second, this will be useful in hypothesis testing. Let's suppose you collect 2 samples. Let's say that I have this classroom of 100 students. I collect a 10 student sample. And then, I maybe want to do one more research and I want to do one more sample. So I collect a 12 student sample. So from the same population, you are collecting 2 samples. So when you collect 2 samples, then you will use n and m. So I will have my first sample size is 10 and second as 12. So 2 samples denote their size by n and m. Third, denote a variable by x, right? And the observations by x1, x2, and so on till xn. Okay. So I can say, suppose x is age of these students. So x1 represents age of first student. x2 represents age of second student. And so on. So you represent x1, x2 till xn as the ages of the different students. I hope this is clear. Now, let us go to the first technique, beta, and this is known as stem and leaf display. Okay. What is stem and leaf display? It is a technique that is used to go ahead and classify the variables. The variables can be discrete or continuous. The aim is to somehow show them in a more better way, in a more enhanced way, right? So we can say that stem and leaf display is a technique to classify discrete or continuous variables. Now try to learn how I will do this. So what I will do is, there are multiple steps in this. The first step is to go ahead and select one or more leading digits. So leading digit selection. I will give you an example, don't worry. The first step is to go ahead and select a leading digit. Whatever leading digit you will select, that will be called as the stem, right? Because secondly, you will select what is called as the trailing digits. The trailing digits will become the leaf. Okay. Okay, beta. So then you will have the trailing digits, and the trailing digits will be called as leaf. Third, after you have selected what your stem and leaf will be, you will go ahead and put stem in vertical column. Right? And you will record leaf corresponding to stem. अब समझो क्या किया मैंने. I am saying go ahead and select stem. But I am explaining, don't worry. Abhi to I have not started. Dekho. I am saying that I am selecting stem and leaves for the data. So dekho dhyan se. Suppose you are given this data set 23, 58, randomly I'm writing 62, 62, 63, 65, 67, 68, 71, 72, एक और 71 ले लेते हैं 71, 72, 80, 82, 84, 84 ऐसा कुछ दिया हुआ suppose. Now, what am I saying? I am saying leading digit selection becomes the stem. Leading digit माने क्या होता है? The 10th digit. That will come out as your stem. So what will I write? I will have my leading digit, and that will be 2, 5, 6. बेटा एक ही बारी 6 लिखोगे, बार बार नहीं लिखना है, ठीक है? 2, 5, 6, 7 and 8. These are my leading digits. Leading digits माने ये हो गया tens and ये हो गया ones. Tens, ones, tens, ones. जो भी tens की place पे आ रहा है, that is your leading digit. ठीक है बेटा? अब क्या करना है ना? I know that I have digits from 2 to 8. So sometimes what some books will do na, that they will fill in this blank also. Matlab, they will write digits in between also. So they will go ahead and they will write 3 also and 4 also. ये हो गए हमारे stems. This becomes my stem. Now what I will do is, corresponding to the stem, it says the second step is to go ahead and get the trailing digits, and those will become your leaves. So beta leaf ho gayi anything that comes in the ones position. So here I will go ahead and I will say leaf. Leaf क्या हो गई? 2 से related तो सिर्फ 3 आ रहा है, तो 2 की leaf हो गई 3. 3 और 4 से related कोई leaf नहीं है, leave it blank. 5 से related leaf है 8, put 8 here. ठीक है जी? Then 6 से related leaf हो गई 2, 2, 3, 5, 7 and 8. So put these leaves 2, 2, 3, 5, 7 and 8. ये हो गई 6 से related leaves. Then बेटा 7 से related हो गई 1, 1, 2. So put here 1, 1, 2. ठीक है? 8 से related 0. You have to write 0 also. Because 0 को blank अगर समझोगे तो गलत होगा. Blank सिर्फ तब आएगा अगर वो number exist नहीं करता. So 0 is also a digit, right? So I will start with 0 beta. 0, 2, 4 and 4. So this is what a stem and leaf is. What have I done? I have written all stem in the vertical column, and corresponding to each stem, I have recorded the leaf. Okay, that is called stem and leaf. Now, why do we want to do this? Iska kya meaning hai? Why are we doing this? Why are we representing it? But one thing, at any point of time, from stem and leaf, you can go back to the number. जैसे मुझे पता है मेरा number 23 रहा होगा, फिर 58 रहा होगा, फिर 62 रहा होगा, फिर 62 रहा होगा, 63 रहा होगा. So from stem and leaf, I can go back to my original numbers also. That is not difficult. ठीक है जी? So first of all, that's the thing. That typically ये एक better representation दे रहा है, और कभी भी इससे हम वापस डेटा पर जा ही सकते हैं. But the important part is that it helps you identify gaps in the data. For example, I know that there is data missing in 30s and 40s. There is no one in the 30s and 40s, right? Similarly, it helps you understand whether your data is symmetric or not. For example, I know कि highest जो frequency के numbers हैं, they lie between the 60s क्योंकि यहाँ पे इतने सारे numbers form हो रहे हैं. So it helps me understand whether my data is equally spread or there is some, some class in which I have a very high number of data points. जैसे यहाँ पे 62, 62, 63. तो 60s में बहुत सारे numbers हो सकते हैं. And इसी से I want to come to my next point, that it helps me understand peaks in the data. So I know because 60s में इतने सारे numbers हैं, this must be the peak. जो 60s वाली line होगी उसमें frequency बहुत high है और बाकियों की frequency comparatively कम है. So I understand where I am attaining this peak. Right? So how many peaks are there? यहाँ पे बहुत सारे numbers हैं. 60s की frequency बहुत high है. 70s और 80s की comparatively बाकियों से ज़्यादा high है. So I can know the number and location of peaks. And at last, you can know the presence of outliers also. So imagine something like this. Suppose I tell you that here I have 9, 10, 11, 12, 13, 14, 15, 16. यहाँ पे कोई भी data नहीं है. And all of a sudden, I had a number 161. यहाँ पर आ रहा था number. I clearly know that this is an outlier to my data set. क्योंकि ये एक अकेला नंबर है जो बाकी डेटा सेट से बहुत दूर है और जो कहीं से भी किसी और से कनेक्टेड नहीं है, right? Maybe even I can think that 23 is an outlier because all other numbers are between 50s to 80s. So it helps me understand whether my data has an outlier or not. Okay, so that's the first technique which is known as STEM and D. Let us go to the second technique, beta. And the second technique is called as frequency tables. So let's take some data set. Let's say I have age of students given to me. And this age of student is given like this: 5, 7, 5, 9, 11, 7, 7, 6, 9, 9, 9, 10, 12. I'm just randomly taking some numbers, 12 and 7. This is the data given to you. I can go ahead and I can represent this data in the form of a table. So what can I say? I can say that, okay, let's take age here and let's take frequency here. And now I will go ahead and I will start mapping this. So I can say, okay, the lowest age that I have is 5. How many people have an age of 5? 1, 2, and that's it. So the frequency is 2. Then the second is 6. How many have 6? Just 1. Then I have 7. How many have 7? 1, 2, 3, and 4. Then I have 8. How many have 8? 0. Then I have 9. How many have 9? 1, 2, 3, 4. Then I have 10, which has 1. 11, which is 1. And finally 12, which is 2. So I have gone ahead and I have mapped age to frequency, right? When I go ahead and I do that, that is called as a frequency table. Is this clear? So frequency table is very easy to make. You just have an age mapped to frequency. Now, what can be done is that you can go ahead and you can make something which is known as a dot plot from it. Dot plot is just representation of frequency table in terms of a diagrammatic approach, right? Diagrammatic approach is where you go ahead and you show these frequencies in terms of a dot format. So let's see this. So let's say that I am again going to go ahead and write these only, beta. So I have 5, 6, 7, 8, 9, 10, 11, and 12. Now with 5, I have 2. So I will write 2 dots. 1, just leave a gap also here. 1 and 2. With 6, I have 1 dot. So 1. With 7, I have 4 dots. So 1, 2, 3, and 4. With 8, I have 0 dots. So no dot. With 9, I have 4 dots. Right? With 10, I have 1. 11, I have 1. And 12, I have 2. So when you go ahead and you show them like this in a dot process, that is called as a dot plot. बहुत simple, the word itself is suggesting what should be done. Now come to the next one. It is called as histogram. This is where you will get your, मतलब अगर visual से MCQ आता है, then you will get your maximum MCQs from this only. This is where the most tricky aspects will lie. So now let us go ahead and understand what this is talking about. A numerical value, first of all, try and understand this thing, can either be discrete or continuous. So I want to begin with a variable. Remember, yesterday I told you variable can either be numeric or it can be qualitative. So we have done quantitative and qualitative. Right? Quantitative or which one? Numeric. Now I am saying that these numeric values, they can either be discrete or continuous. Right? When I say discrete, but discrete is anything which is either finite or infinite sequence. Sequence माने कि I am writing it in terms of finite or infinite sequence of numbers. जैसे for example, यहाँ पे of numbers. When I say that I want to go ahead and I want to give the rank of the students. Rank can be either first or second or third and so on. There cannot be any number in between. I cannot have a continuity achieved. So when I talk about my number line, right, I will either have 1 or 2 or 3 or 4 and so on. You are not including what is coming in between 1, 2, 3, 4, 5, 6 and so on. So when you have like that, that is called discrete. Now think about continuous. When I say continuous, continuous is when you are able to include your entire gap also. So I can say entire interval. Just say for example, let's say I am checking the pH value of any chemical substance. And I know that this pH value can be anything between 0 to 14. So between 0 to 14 mein, I am including all possible values. Matlab it can be 0.2, it can be 7.8, it can be 9.33. So I am not including only discrete numbers. I am including every number between 0 to 14, including integers, right? Every possible thing that comes between 0 to 14 is included. Then that becomes continuous. So discrete is when you only include these, but nothing in between. And continuous is when you include the entire interval, but everything inside that interval is also included. Okay. Now, we will first start our histograms with discrete. But before we do that, I want to go ahead and I want to talk about frequency. So when I talk about frequency, what is frequency? The number of times, all of us are aware, the number of times that your variable occurs in the data set, that is frequency. So I can say any particular X, whenever it appears the number of times, that number of times becomes the frequency. This is what we already know. But can you write these examples of quantitative variables? Did I write these? You can just, yes, you can just give some examples here. You want me to write more? Age of a person. That is discrete. Okay. And continuous variable can be the income of person if you want to include all possible numbers in it, right? So then the example can be, as I gave, rank. That's a discrete variable, right? So you wanted me to write these examples, is it?
Yes, ma'am.
Okay. So these are some of the examples. I mean, see, anything that I will be measuring, like for example, many books, they talk about the strength of a chemical, how easily or difficult it is to break a chemical, right? So when I talk about strength of chemical, it is in decimals also, it is continuous. But suppose I ask you, what are the number of deaths from COVID? Then it has to be a number. It cannot be in digit, in points. Either 2 people have died or 3. I cannot have 2.4 people dying, right? So it is discrete. So when I say discrete, you should not be including any decimals. When I say continuous, you can include everything in the interval. Okay. Now, when I talk about frequency, we are pretty clear with what frequency is. But today I want to talk about something which is known as relative frequency. What is a relative frequency? A relative frequency is very important to make a histogram. And how do I make that? It is number of times the value occurs, that means frequency, divided by the number of observations in dataset. Right? Let's say that, let's go back here. So for each group, I have written the frequency. Mane 5 occurs 2 times, 6 occurs 1 time, and so on. Let me quickly go ahead and add this together. Can you tell me what the sum is coming out to be? So 2 plus 1, 3, and 4, 7, 8, 9, 10, 14, and 15. The sum is coming out to be 15, right? Now, when I go ahead and I have to find relative frequency, what does that mean? I will do 2 divided by 15. So frequency divided by total. 1 divided by 15. 4 divided by 15. 0. 4 divided by 15. 1 by 15. 1 by 15. 2 by 15. If you see here, the sum of relative frequency should always be 1. Have a look. If I just add this, beta 2 by 15 plus 1 by 15, you're adding all these. तो जो numerator है वो तो यही था. Denominator तो 15 ही है. And numerator का ही तो sum 15 था. So you just have 15 by 15 coming up, which will be 1. So the sum of relative frequency is always 1. Very useful concept. A lot of times they will just ask you, what is the sum of relative frequency? So you should be aware that it is just one. Let's take another example. Suppose I give you a question like this. So I tell you, let X, it represent the number of courses a student takes in a semester. So a student can take 1 course, 2 courses, 4 courses, and so on. He has a choice between 1 to 6 courses that he can choose in one sem. Now, I am saying, suppose my N is 200. There are 200 students in the class. And now I am saying you that beta X is equal to 3 is 70. Samjho baat ko. Matlab there are 70 students who have taken 3 courses. 70 students who have taken 3 courses. Can you tell me what will be the relative frequency of these students? Yes, 70 divided by 200, which will be 0.35. So I know that 0.35. Achha, you can convert this in percentage also. Into 100 agar kar doge, that means 35% of students, they have taken your 3 courses in the semester. Are you getting it? So relative frequency is also going to help you to identify the percentage. And in very simple terms, it is telling you what is the proportion of people who are doing a particular task. Now, from here, I want to go ahead and I want to talk about histogram. So a histogram basically is when you have diagrammatic approach of these relative frequencies. Take an example. Suppose again, I want to talk about these same students who can take different number of courses in the class. And I tell you, these are the better number of courses that they have taken in one semester. Apni choice hai ki ek course lo, ek bhi mat lo ya 6 lo. So you can either take no course at all, 1 course, 2, 3, 4, 5, and 6. And I've given you some frequency here. That number of students who take 0 courses is 20. And you can just fill this grid: 72, 38, 40, 100, and let's say 20 and 10. Okay. First thing that I want to do is I want to go ahead and I want to make relative frequency. So for that, I will add this up. So I will get 10, 20, 300. That is what I will get. Now I will divide. So I will say 20 divided by 300, 72 divided by 300, 38 divided by 300, and so on. So better quickly use a calculator and just try to fill this up. Do it with me. This is a practical subject. You should be writing your answers with me. So this is 0.067. Then you will get 0.234. Then you will get 0.126. Keep doing this. 440 by 300. You will get 0.134, 0.334, 0.067, and 0.034. Please verify it once that you are getting these digits only. Now, I want to go ahead and I want to show them in a diagrammatic way, in a histogram manner. So what can I do? I will go ahead and I will make a diagram like this. So I will take X here. X represents the number of courses taken. And I will take relative frequency here. Okay. And now I will say relative frequency, remember, is between 0 to 1. 1 se upar nahi ho sakti, because you are dividing a small digit by a bigger one. Hai na? So it has to be between 0 and 1. And you can go ahead and you can assign some intervals. So maybe I can say, okay, 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, ऐसे करके you can go till 1. Now, what am I going to do? My values also, beta, are between 0 to 6. So I will write 0 here. It's a value. 1 here, 2 here, 3 here, 4 here, 5 here, and 6 here. I've written different values. Now what I'm going to go ahead and I'm going to do is this 0 that I'm writing here, this acts as a midpoint. मतलब जैसे 0 की frequency 0.067 है, मतलब 0.05 से थोड़ा ऊपर. So I will draw my histogram like this. So what have I done? I have gone ahead and I have taken 0 as the midpoint of this histogram. ये जो बार बनाया है, इसका midpoint जो है, center जो है, that should be aligned with 0. And I think ये थोड़ा सा midpoint नहीं लग रहा है. So make sure that it looks like a midpoint. Similarly with 1. So 1 की frequency है 0.23. So 0.25 से थोड़ा नीचे. Then I will just go ahead and draw like this. So it should come from the midpoint. That is what is important. 1 should be aligned to the midpoint. Same you can draw for others. So आप 2 की कुछ बना लेना. जो भी values दी होंगी ना accordingly. 3 की बना लेना. I'm just drawing it randomly. 4, 5 ऐसे करके बना लो. Now, you can also draw something which is known as a smoothened curve from a histogram. What is a smoothened curve? To draw a smoothened curve, you will join these center points together and get a line. So for example, when I join these center points, I will get something like this. Like this. So this will tell me exactly how my pattern looks. It will tell me how ultimately where are my peaks and where are my troughs, right? And you will use this in economics also. जैसे कब recession हो रहा है, कब depression हो रहा है, कब boom आ रहा है economy में, वो in GDP को अगर मैं ऐसे map कर दूं, I should be able to understand that. So what I can do is, if I just want to draw these smoothened curve, then I will get this. You have to draw it in a separate diagram, but I'm telling you that from histogram, you can go ahead and you can get smoothened curves also. Now, sometimes what will happen in exam is that they will give you a histogram like this. Okay. And now they will ask you a question like this. So suppose they ask you, what are the proportion of students who have taken at most 2 courses? वो कितने स्टूडेंट्स हैं परसेंटेज में जिन्होंने at most मतलब मैक्सिमम 2 कोर्स लिए हैं? It means बेटा, I want to add the relative frequency of students with 0 course, then with students who have taken 1 course and students who have taken 2 courses. So how many students took 0 courses? Beta, this is 0.067. 0.067. How many took 1 course? It is 0.234. And how many took 2 courses? It is 0.126. So if you add this together, you will get 1017 to 0.427. ठीक है जी? Please verify this answer for me. So if I have to give my answer in terms of percentage, I can just multiply this with 100. That means 42.7% of the students have taken maximum 2 courses in this semester. 2 से ऊपर courses नहीं लिए हैं 42.7% बच्चों ने. So relative frequencies can help you answer these questions, that what are the proportion of students who have taken at least 2 courses, at most 2 courses, एग्जैक्टली 2 कोर्सेज। तो ऐसे क्वेश्चंस भी आप रिलेटिव फ्रीक्वेंसी से आंसर कर सकते हो। नाउ but this is discrete data. Now I want to go ahead and I want to construct histogram for continuous data set. So whenever you have to go ahead and you have to draw a histogram for continuous data set, what will you do? You will subdivide your measurement axis into suitable number of class intervals. ठीक है? These class intervals can be equal or they can be unequal. So to begin with, let us start with equal class intervals. ठीक है? Let me take an example. Suppose you're given some data set on the fuel efficiency of cars. ऐसा कुछ माइलेज के ऊपर डेटा सेट है कि हाउ एफिशिएंट योर कार्स आर, राइट? एंड इन दिस डेटा यू आर गिवन सम वैल्यूज एंड वैल्यूज आर लाइक दिस 27.8, 28.4, 29.3, 30, 32.1 ऐसा करके कुछ दी हुई है सपोज. And suppose let's say you from the data set identify what is the highest and lowest value. So you understand that the lowest value is 27.8 and the highest value is 31.4. ठीक है? ये continuous data set है. So शायद हर नंबर सिर्फ एक एक बारी ही आ रहा होगा, उनकी कोई frequency नहीं होगी. But you are very clear that you have a particular range in mind. Range मतलब highest and lowest value is known to you. शायद यहाँ पे और नंबर्स भी हो, जैसे यहाँ पे 27.99 हो, एक नंबर 30.254 हो, बहुत सारे नंबर्स है. But I have identified the highest and lowest value. So I know that from here, my highest value that I have, that highest value is 31.4. And I've identified that the smallest value that I have, that smallest value is 27.8. What can I do? I can make equal or unequal intervals. By equal, I mean that I will divide my entire data set in some intervals which include these values also. So for example, I can do something like this. I can start from 27.5 and I can take an interval of 0.5 each. So I can go to 28, 28.5, 29, 29.5, 30, 30.5, 31, and 31.5, something like this. So what you have done is you have divided this data set that you could see in intervals. Now, wherever you see value between 27.5 to 28, you're going to go ahead and make a histogram. Okay, so suppose there are 10 values between 27.5 to 28, then accordingly, I will have 10 values here. Maybe I have 12 values here, I will have 12 values here, and so on. So the first thing which is possible that you can do with your data set is that you can divide the continuous observations into class intervals. But even in this case, when you do this, make sure that whenever you plot these histograms, they are based on relative frequencies. So you still have to calculate relative frequencies. You should not be working with the actual frequencies. जैसे हमने यहाँ पर convert किया था ना हर चीज को relative में. It is important that you convert these also into relative frequencies. Let me give you an example. So write down an example. Let's say that I have class intervals given to me. Class intervals से अपने आप आपको ये hint मिलना चाहिए that this is a continuous data set that you are working with. So my class intervals are given to you 1 to less than 3, 3 से लेके less than 5 तक, 5 से लेके less than 7 तक, 7 से लेके less than 9 तक, 9 से लेके less than 11 and 11 से लेके less than 30. Keep writing, ऐसा कुछ आपको दिया हुआ. Now, you are already given in this case relative frequency. But how do I know that this is relative frequency? If the sum is coming out as 1, it means that they have already given me relative frequency. So supposedly they have given me 0.011, 0.011, 0.122, 0.233, 0.278, 0.189, ऐसे करके आपको डेटा दिया हुआ 0.100, 0.044. So when you are given a data such that the sum is coming as 1, you are clear that this is where you are talking about relative frequencies already. अगर नहीं दिया होता तो हम कन्वर्ट कर लेते फ्रीक्वेंसी को टोटल नंबर से डिवाइड करके. Now, what will you do? यहाँ पे I think so data, this had one more value, 17 to less than 19, 0.011. Now, you just have to make a histogram out of it. So to make this histogram, what can you do? You can just say my data starts from 1, then I have 3, then I have 5, 7, 9, 11 and so on. Now between 1 to 3, how many, what is my relative frequency? 0.011. तो बेटा यहाँ पर फिर से शुरू करना 0.005, 0.10, 0.15, 0.20 ऐसे करके लिख लिया. And then between 1 to 3, I have 0.011. That means it is less than this, something like this. Then the next one is 0.011. Again, same. Then the next is 0.122. मतलब 12 हो गया ना, 10 से बड़ा हो गया. So it will be somewhere here. And so on. So basically, my entire agenda is that whether you have a continuous data set or you have a discrete data set, for both you can go ahead and you can draw the histogram. When it was a discrete data set, तो आप उसके midpoint से निकाल रहे थे क्योंकि single values थी. But when it is a continuous data set, तो आप इसकी continuity को consider कर रहे हो कि 1 to 3 के बीच में कितनी values है, 3 से 5 के बीच में कितनी values है, and so on. Now, sometimes student ask a very important question, and I was expecting someone to ask that how do I know कि मैम अगर मेरा डेटा 27.8 से 31.4 के बीच में है तो मैं कितने इंटरवल्स बनाऊं? I mean, आपने 0.5 के ही इंटरवल्स क्यों बनाए? Why did I make this? I could have very well made the interval from 27.5 to 28.5, 28.5 to 29.5. अगर मैं ऐसा करती तो शायद सिर्फ 5 इंटरवल्स बनते. अब जब हम ऐसा कर रहे हैं तो 10 इंटरवल्स बन रहे हैं. So the question that students ask, how many intervals are apt? Is there any thumb rule for it? The answer is yes. You have a thumb rule for the number of intervals that you can make. And what is the thumb rule? The thumb rule, yes, so you're correct, beta. Ease and difficulty to plot to hai, but you have a thumb rule, mathematical rule, that the number of classes should approximately be equal to under root of number of observations. This is what books like DeVore, author like DeVore tell us. That suppose जो ये मेरी observations थी यहाँ पर, ये observations, suppose ये जो पूरा data set था, ये 100 observations का था, right? So I had 100 such values, fuel efficiency values, 100 cars का data मेरे पास available था. Then I will make 10 classes. So then root of 100 will be 10. So 10 classes मतलब कि जितना भी मेरा data set है, 28.5 first value है suppose, and 32.5 second value, last value है, इनके बीच में मुझे ऐसे divide करना है that I get exactly equal 10 classes, right? So how many classes will you define? Will be under root of the number of observations, right? Is this clear? Does this mean number of classes would always be a whole number? Yes, classes should always be a whole number only, right, beta? Because classes cannot be integer, because I have to define this is class 1, 2, 3, 4, 5. These are my classes. So I cannot have 5.5 classes. Either I will stick with 5 classes or 6 classes. Class is what you have here. Okay. Now, when I talk about my histogram, I have already told you that not always equal width is desirable. A lot of times you will have to go with unequal widths. Equal width का क्या मतलब हो गया? Equal width का मतलब ये हो गया जहां पे हमने हर एक की गैप जो है वो 2 का रखा. 1 2 3 गैप ऑफ 2, 3 से लेके 5 तक गैप ऑफ 2, 5 से 7 तक gap of 2. So I am keeping equal gaps. But always equal gap is not desirable. Sometimes you should be going with unequal gaps also. Take an example. Suppose beta, your data set is like this. You're given a dot plot, and the dot plot looks like this. I have many small intervals. And I see that I have one frequency here, one here, many frequencies here, and one here. When you see such dispersed frequencies, मतलब यहाँ पे तो बहुत सारे data points रहे होंगे, but यहाँ पे इस interval में सिर्फ एक data point था, इस interval में एक था, इसमें एक भी नहीं था, एक भी नहीं था, एक भी नहीं था, एक भी नहीं था, एक भी नहीं था और एक था. So when you see such dispersed plot, when you see that there is one interval in which multiple data points are there, and in other intervals, we don't have much data points. In that case, you should be going with unequal width. Unequal मतलब यहाँ से लेके यहाँ तक को एक ही इंटरवल बना दो ना, क्योंकि यहाँ पे मिलाकर भी सिर्फ 2 ही डेटा पॉइंट्स आ रहे हैं. यहाँ से लेकर यहाँ तक सिर्फ एक ही डेटा पॉइंट है, एक ही इंटरवल बना दो ना, और इनको अलग अलग छोटे छोटे इंटरवल्स बनाओ क्योंकि यहाँ पे बहुत सारे डेटा पॉइंट्स है. सो अनइक्वल विड्थ मींस you will divide your data not equally but unequally. Your width will differ. I can easily identify that using dot plots. So in case of dot plots, what should we be doing? We should see how my data is spread. And if I see कि कुछ intervals में बहुत कम data है और कुछ में बहुत ज्यादा है, तो जहां पे बहुत कम है उनको combine करके एक interval बना दो, और जहां पे बहुत ज्यादा है make them into small intervals. Okay. Now, in this case, when you will make a histogram, then beta, you should be calculating rectangle height through a formula. And this formula is relative frequency of class divided by the class width. बहुत ध्यान से समझो. देखो यहां पर ना क्लास विड्थ बराबर थी सबकी, तो यहां पर मुझे कोई जरूरत नहीं पड़ी थी कि मैं रेक्टेंगल की हाइट के लिए कुछ एक्स्ट्रा करूं. अगर मैं हर एक को क्लास विड्थ, हर एक की क्लास विड्थ कितनी थी? 2 की. द गैप बिटवीन 3 and 1, 5 and 3, हर एक का गैप 2 का है. सो अगर मैं हर एक को क्लास विड्थ से डिवाइड भी कर देती, सिर्फ रीस्केलिंग होती. इट वाज जस्ट रीस्केलिंग, नथिंग वाज चेंजिंग. Why nothing was changing? Because ultimately you're dividing it by the same number. Now, suppose I have unequal classes. जैसे for example, ये वाली जो class है, last दो, let's say that this class is 15 से लेके less than 20. And this class is 20 से लेके less than 30. But now I have unequal classes. I cannot directly plot these relative frequencies now. It will be wrong because the gap between the classes is not the same. So what will I plot now? Not the frequencies. अभी तक तो हम इस frequency को ही plot कर रहे थे ना. ये 0.011 था, ये 0.011 था, यही तो वैल्यूज को हम प्लॉट कर रहे थे. But now what I will plot will be doing one additional step, relative frequency divided by class size. तो इसका class size तो 2 है, तो 0.011 divided by 2. But इसका class size 10 है, the gap is 10. So it will be divided by 0.011 divided by 10. It is spread across 10 data points. And this is just spread across 2 data points. So we have to take into consideration this also. And this, when you do this, then beta, this value that you get, this is called density. Again, an important MCQ question. What is density? And when you plot these, वो जो rectangles बन के आते हैं, they are called as density scale. So why is density important? Density important इसलिए है because the class intervals are not equal. So if the intervals intervals are not equal, I cannot directly plot this relative frequency. कोई तो सिर्फ 2 data points के across spread है, and something is spread across 10 data points. So it is not possible to go ahead and to directly plot these. Is this clear? Now let us go ahead and take an example, and then I will leave you for the day. So take an example. Suppose I tell you class. The class is 2 से लेके less than 4. The class is 4 to less than 6, 6 to less than 8, 8 to less than 12, 12 to less than 20, and 20 to less than 30. Right? And we go ahead and we have frequency here. And I give some frequencies. Beta 9, 15, 5, 9, 8, and 2. What's the first step? You have to calculate relative frequency. कैसे करोगे relative frequency calculate? Sum this up and then divide. तो इसका sum आ रहा है 48. So relative frequency will be 9 divided by 48. 15 divided by 48. 5 divided by 48. 9 divided by 48. 8 by 48 and 2 by 48. ये हो गई relative frequencies. So you will get some number 0.1875, 0.3125. I urge you, please do these on your own. Please just don't copy paste. घर जाकर एक बारी खुद से इसको लिखना जरूरी है. I will give you the assignments also, by the way, from now. These are your relative frequencies. Now I want to talk about density. So beta, what was density? Relative frequency divided by the class interval. So ये हो जाएगा 0.1875 divided by 2. ये हो जाएगा 0.0417 divided by 10 and so on. तो यहाँ पे आपकी कुछ values आ जाएंगी. This will be 0.094, 0.156, 0.052, 0.047. Please do them on your own also. ये आपकी values are. I want to go ahead and I want to plot these. This is what I want to plot. So when I draw this histogram, here I have 2, 4, 6. ये बेटा यहीं से देख लेना. 2 से 4 है, 4 से 6, 6 से 8. But 8 से सीधा 12 है. फिर 12 से सीधा 20 है. And 20 से सीधा 30 है. So the gap will increase. Look at this gap. 2 का gap है. Look at this gap. Look at this gap. 8 and 10 का gap है. 4 का gap है. So accordingly you will show these gaps. And now just go ahead and plot these values. So the first value is 0.094. Again, I am leaving it up to you. You can plot these. यहाँ ले लेना 0.05, 0.10, 0.15. And accordingly, you will just plot these and you will get a diagram out of it. Okay. So what I want to show is that beta, here you have density now. You no more have relative frequency. You have density. one last thing that can come in MCQ. एक बात बताओ, density क्या थी? Density was relative frequency divided by class width. है कि नहीं है? Relative frequency divided by class width. So बेटा relative frequency क्या होगी? Density into class width. This will just go here. Relative frequency will be density into class width. अब ध्यान से समझ के बताओ कि जो हमारी क्लास की width है, जो मेरी क्लास की width है, width, ये इस रेक्टेंगल की breadth है ना? So this is the breadth of the rectangle. और जो मेरी यहां पे डेंसिटी है वो इस रेक्टेंगल की हाइट है ना. दिस इज हाउ दिस रेक्टेंगल इज प्लॉटेड. एक्स एक्सिस जो थी वो ब्रेथ थी रेक्टेंगल की एंड वाई एक्सिस जो थी वो हाइट थी. सो बेटा कैन आई से दैट द विड्थ ऑफ द क्लास actually represents the breadth of the triangle and the density represents the length of the triangle. बेटा लेंथ इंटू ब्रेथ तो एरिया ऑफ द ट्राइंगल ही तो होता है, सॉरी एरिया ऑफ रेक्टेंगल. सो दिस इज वेरी वेरी इंपॉर्टेंट कंक्लूजन, अगेन वेरी इंपॉर्टेंट फॉर योर एमसीक्यू पार्ट, दैट द रिलेटिव फ्रीक्वेंसी इज इक्वल टू द एरिया ऑफ रेक्टेंगल इन हिस्टोग्राम्स. ये जो एरिया निकल के आया है, दिस एरिया, इसका जो एरिया है, if someone asks you what is the value of this area, it is nothing but the relative frequency. This is what we have proved. So अगर मैं रेक्टेंगल नंबर 2 का आपसे एरिया पूछूं, बेटा वो कुछ नहीं है, वो सिर्फ रिलेटिव फ्रीक्वेंसी है. ठीक है, और रिलेटिव फ्रीक्वेंसीज का सम क्या होता है? 1. So which means if I draw all these rectangles, इन सारे रेक्टेंगल्स के एरिया का सम, the sum of areas of these rectangles will be 1 because they just represent relative frequencies. So I will conclude my session with this. I want you to please write this down. Please write that sum of relative frequencies is 1. Write that relative frequency is nothing but the area of rectangles. So the sum of area of rectangles will be 1. Okay. Very important conclusion. Histogram में से easy चीजें नहीं आएंगी, आएंगी तो difficult चीजें आएंगी. So we should be aware about these concepts. Okay. So we'll end here for today, and then in the next class we begin with mean, median, mode, etc. Thank you.
So the topic that I want to begin with today, that is going to be the measures of central tendency. Make a new register, write everything down in that notebook. All questions in one notebook, whether they are easy or difficult. Measures of central tendency. Now, when we talk about the measures of central tendency, we basically are talking about, so first of all, why do we need measures of central tendency? Measures of central tendency basically go ahead and they help us understand how the data overall looks, right? It gives us, it's a statistical way to understand the center of the data, right? In a way, one value that is helping me understand a bit more of the data. So for example, when I talk about average marks, जैसे मैंने बोला कि ठीक है, there are 100 students in the class. What is the average marks of this class? So it is giving me some information about that class कि ठीक है, on an average, students in this class secure this much marks, right? Or if I ask you what is the mode of the class, right? Modal marks. It means somewhere I'm asking that which is the marks obtained by most of the students, which marks has highest frequency. So whenever we talk about measures of central tendencies, का क्या मतलब है? सेंट्रल टेंडेंसी मतलब कोई एक ऐसी वैल्यू जो सेंटर में है, विच इज नॉट एग्जैक्टली सेंटर, बट कोई एक ऐसा वैल्यू, एक टिपिकल वैल्यू जो पूरा का पूरा डेटा को समराइज कर रहा है. इट इज हेल्पिंग अस समराइज एन एंटायर डेटा, right? Whether it is average, whether it is through median, whether it is mode, but it is helping us to summarize the entire data set, right? So please write it with me that the measures of central tendency are helping to summarize an entire distribution through one data point. So one point is helping me understand the entire distribution. Now, the first measure of central tendency, which we want to do, that is called as arithmetic mean. Right? When we talk about arithmetic mean, there are two main types that we want to study. One is simple arithmetic mean, and one is weighted arithmetic mean. So there are two kind of arithmetic means which are there. Okay, so beta, I've just started with measures of central tendency. I just mentioned that central tendency is one number which is summarizing the entire data set. पूरे data को हम किसी एक number के through, whether it is mean, median or mode, we are trying to summarize the entire data set through that one number, right? And then I'm just talking about arithmetic mean. We have just started telling what is arithmetic mean. Okay. So when we talk about simple arithmetic mean, this is my first topic. Simple arithmetic mean, it means that I want to find the average of the data set. We want to find the average of the data set. Okay. This average sometimes is very useful. Just for example, let's say that I have section A consisting of 10 students and section B consisting of 10 students. And I want to ask which section performs better on an average. कि अगर मैं एक test दोनों sections को दे दूं, section A and section B को, what do you think? Who has a better result? Which section is the one which I should be probably showing to other schools? कौन सा section है जो अच्छा perform करके दिखा सकता है? The average can be useful. I can find the average marks of both the sections, and whichever section on an average has higher marks, probably that will be a better section to represent my school. So many times when I cannot look at individual points, at individual data points, at that point, the average becomes very important. अगर मैं हर एक बच्चे को एक बच्चे से compare नहीं कर सकती हूँ, that is a very tedious and difficult task, then in that case, finding out the average is going to be very useful to me. In this simple arithmetic mean, the first case is when frequency is not given. It means you have discrete data points. Frequency is not given to you. You have discrete data points. माने simple कोई data दिया हुआ है. You are given x1 as 2, x2 as 3, x3 as 4, and so on. Okay, you're just given numbers and you've asked find the average. So very simple. In that case, my mean will be 2 plus 3 plus 4 divided by 3. So in general, in such cases, the formula, excuse me, the formula of mean is x1 plus x2 plus x3 till whatever number of observations are there divided by the number of observations. So this is 9 divided by 3, which means 3. So if frequency is not given, then mean is going to be x1 plus x2 till xn divided by the number of observations. Right? This is the first method. Okay. Now, in this case, we are still within frequency not given or discrete data points. There is also something which is known as shortcut method. Right? The first formula that I have written, that is the formula of direct method. Shortcut method basically goes ahead and says the following, that the mean is going to be A plus submission D divided by N, right? Where D will be Xi minus A, where A is assumed mean. A is assumed mean. Assumed means what? You pick up any value from the data. आप data में से कोई भी एक center value निकाल लो. That becomes your assumed mean. Okay. Let's take an example of that. So let's say you're given a data set. Okay, you're given income of individuals. Say 1780. Say 1760. Say 1690. 1750 and 1840. You're given 5 data points of income. You will go ahead and you will pick any number. It can be any number out of the data. Okay? And you will call that as your A. A will be your assumed mean. And this is your data, Xi. Then you will do Xi minus A and call this as deviation. Mane 1780 minus 1690 equal to 1760 minus 1690 equal to 1690 minus 1690, 1750 minus 1690, 1840 minus 1690. So you will go ahead and you will find this value of D. Right? Whatever this D is going to be, you can go ahead. Yes, calculator definitely you can use 150%. It will be available. You will go ahead and you will add that. Right? So 1780, just quickly do this. 1780 minus 1690, 90. 1760 minus 1690, 0. 1750 minus 1690, 16. And 1840 minus 1690, 150. You will go ahead and you will add all these deviations together, all these D's together. So if I add this, what will I get? 90 plus 70 plus 60 plus 150. That means 370. And now put it in the formula. So what is my formula? My formula is A plus submission D divided by N. A was 1690. Summation D is 370 divided by number of observations. That means 5. Okay. 1764 will be your answer. So this is your method number 2. It is called as shortcut method. Shortcut method is any method where you will be basically given an A. You will be taking an assumed mean and you will be solving. When you do that, it is called as shortcut method. Okay. Beta method number 3. This is long cut here, but as you move with the data, when you go to continuous data sets, this actually acts like a shortcut method. Okay. Now method number 3. This is called as step deviation method. It is called as step deviation method. Step deviation method is where x bar or mean is equal to A plus submission F di, or we don't want to introduce frequency abhi. So submission di dash upon n into h, where h is some common factor and di dash is di by h. Di by h. So what do I mean? Look here. So what we are saying here is, let me just take the same example that I took here. So for this same example, we want to go ahead and we want to find out di dash. I'm doing it here itself. I want to find out di dash. Di dash can be found out by dividing d with some common factor. Just yahan pe if I notice, the common factor is 10. So I introduce di dash and di dash will be di divided by 10. So I'll get 9, 7, 0, 6 and 15. And I will add that. So if I add this together, I will get the answer as 37. And then I will put it in this formula. So what will be my formula? My mean will be A. A was that same thing, 1690. Summation di dash. Summation of this, that means 37, into h, which was the common multiple, which here was 10. I had divided it by 10. So into 10 upon number of observation, which is 5. So instead of writing 370 here, I have gone ahead and first divided this d by a common factor, added that and multiplied that common factor at the end. It's the same thing only. Mane yahan pe you were getting 370 directly. Now yahan par when you add, you get 37 and you multiply it with 10. So when you solve this, you will get exactly same answer, 1764. So we are talking about 3 cases now. So we have seen 3 cases. Direct case. The second one was shortcut. And the third one was step deviation, right? So I'm just summarizing it here. For data which is discrete, that means no frequency. We saw three cases: direct, shortcut, and step deviation. Direct says do summation xi by n. Shortcut says a plus summation bi by n, right? Step deviation says a plus summation di dash into h by n. We'll always take 10 as common factor. No. Whatever is common with D. यहाँ पे you see ना 90, 70, 0, 60, 150. So I see 10 का factor common आ रहा है. That is why I took 10. Suppose these numbers would have been 20, 40, 0, 40, 80. So 20 could have been taken as a common factor, right? Everything is a multiple of 20. So it depends on what D you are getting. Accordingly, you will take the common factor. Okay, now let us go ahead and look at another kind of data, right? And this is the data where you have discrete data, but with the presence of frequency. So second type of data. With frequency. With frequency means what? You will be given some x, but you will also be given some frequency. So for example, if I tell you that this is marks and this is number of students who obtained those marks, right? So say 20, 30, 40, right? 50, 60, and 70, 8, 12, 20, 10, 6, and 4, suppose. Now, I am given the frequency here. You notice 20 marks were obtained by 8 students, 30 by 12 students, and so on and so forth. So, in such case, the formula for direct method, it is summation xi fi by summation fi. Each x multiplied by frequency added up together divided by sum of frequency. So let's do that. This is x. This is f. So xi fi will be 20 into 8. Just keep multiplying. Just fill in this. 20 into 8. 30 into 12. 80. 500. 360 and 280. So you add all of these together and you will get 2460. Then you add the frequencies together and you will get 20, 30, 40, 50, 60. Put it in the formula. 2460 divided by 60. Right? And this will be 6, 12, 18, 24 and 1. So your average will be it was 800. I just wrote 80 by chance. Your average is going to be 41, right? So we understand that here the formula involves adding frequencies together because the total number of students in the class is 60, right? So my capital N, the total number of students, can be found by adding the frequency together, right? Now in this also, you can have shortcut method. So if you can do by direct, उसी पे छोड़ दो. Right? In exam, वो ये नहीं बोलेंगे use shortcut method or use direct method or use that. And you just have to find the mean, right? Up to you which method you want to use. Agar direct method is fine to you, you use this, right? So shortcut method here says that mean is equal to A plus summation FD by summation F. Again, just take the same question and try to find mean. So X will be 20, 30, 40, 50, 60 and 70. And my frequency is 8, 12, 20, 10, 6 and 4. Now I take some assumed mean. कोई एक नंबर को assumed mean ले सकते हो. Suppose 40 को ले लेते हैं. You call this A. And you do xi minus A. And this is called as D. So 20 minus 40. 30 minus 40. 40 minus 40. 50 minus 40. 60 minus 40. 70 minus 40. So what do we get, beta? Minus 20. Minus 10. 0. 10. 20. 30. So you get 30. अब but summation D नहीं निकालना है. D into F करके sum करना है. So you will find D into F. So 8 into minus 20 minus 160. 12 into minus 10 minus 120. Quickly fill this up, beta. 100, 120 and 120. Add this together. You will get 60. Put it in the formula. So assumed mean hai 40. This is 60. And summation of frequency is 60. So you will get 40. You will get the same answer. I mean, answer is 41 only. Just that this is another formula to calculate it. और ये formula क्या बोल रहा है? ये formula बोलता है that mean is A plus summation F into D divided by number of observation. Number of observation कैसे निकल सकती हैं? Frequency को add करके. You can find number of observation by adding the frequency together. Okay. Now do it through the third method. Step deviation method. This says that mean will be A plus summation F D dash by summation F into H, where H is the H या I. I mean कुछ भी लिख सकते हो. हाँ, you can write this as I also. Up to you. This is the common factor. This is the common factor. So I take the same question again, and now I will do using this method. So you were given X as 20, 30, 40, 50, 60, 70. And you were given frequency as 8, 12, 20, 10, 6 and 4. I take A first. This is 40. And I find X minus A. X minus 40 in this case. And call this as my D. So 20 minus 40, 30 minus 40, 40 minus 40, 50 minus 40, 60 minus 40 and 70 minus 40. Put down the values. Minus 20, minus 10, 0, 10, 20, 30. Clearly 10 is common. So I find D dash as D divided by 10. Minus 2, minus 1, 0, 1, 2, 3. and I do D dash into frequency. Multiply this with frequency. So it will be minus 16, minus 12, 0, 10, 12, and 12. So you will get plus 6. Put it in the formula and try it. Why divide by 10? Because that is what the method is, beta. We are finding D dash. D dash is when you divide by a common factor. 20, 10, 0, 10, 20, 30 के बीच में common 10 है. Right? So that is why I am dividing it with 10. I mean, you could have divided it by 5. Does not matter. 5 भी common ही है. Right? But the highest factor common is 10. So I am dividing it with 10. So once you get this plus 6, just put it back here. So what will happen? A का value क्या था? It was 40. Submission F into D dash, which is 6. Summation frequency, which was 60. Into I, common factor, which is 10. So this will give me 40 plus 1 equal to 41. So again, the same answer. 3 methods do the same thing. Just that there are 3 different methods to understand this concept. So हमने देखा that even when frequency is present, then also there are 3 methods: direct, shortcut, and step deviation. Now, third kind of data. Continuous data set. In continuous data set, you are given data which is in intervals, right? So for example, if I say marks obtained by students, rather than saying marks 10, 20, 30, 40, etc., you will be given marks between 0 to 10, between 10 to 20, between 20 to 30, 30 to 40, 40 to 50, 50 to 60. So you are given intervals rather than being given the marks in discrete, right? And then you're also given the number of students. So 5, 10, 25, 30, 20, and 10. Now, whenever you are given a continuous data set, at that point, what you have to go ahead and you have to do is, you have to find something which is known as midpoint. And midpoint is always going to be lowest value plus highest value of the interval divided by 2. So midpoint of the first class will be lowest value plus highest value divided by 2. That means 5. Midpoint of the second class will be lowest value of that class plus highest divided by 2. That means 30 by 2. That means 15. So midpoint can be found out by lowest plus highest by 15. Let's say that I denote midpoint by M, right? So M will be 5, 15, 25, 35, 45, and 55. Right? 45 and 55. Now, the direct method, method number 1. So it says mean is submission. Now, there is no X, remember. We have found out the midpoint in this case. I have to work with midpoint. So it is summation frequency into midpoint divided by summation of frequency. Right? That is going to be the formula. How did we calculate midpoint? By finding lowest plus highest by 2. So for each interval, lowest plus highest divided by 2. 0 plus 10 divide by 2, 5. 10 plus 20 divide by 2, 15. Okay, this is how you can find midpoint. Go for direct method. So summation F into M divided by summation F. Okay. Do it. So I'll find midpoint into frequency. Just find these values quickly. So 5 into 5, 25, 150, 625, 1050, 900, and 550. Add them together. $3,300. Find out the mean. So summation of frequency, 100. So this is going to be 3,300 divided by 100, 33. So mean will be 33. Okay. Again, here also we can have shortcut method. So shortcut method says that mean is A plus summation F into D upon summation F. So again, I will find some assumed mean. Let's go back to the same data set. This is my data that I have. And on this, I will apply shortcut method now. Right? So to find shortcut method, I'm just removing this. To apply shortcut method, you need some assumed mean. तो कोई भी midpoint से एक center value ले लो. Okay. Let's say I take the center value as 35. And I call this as my assumed mean. This becomes my assumed mean. So I will do midpoint minus 35 and call this as D. 5 minus 35 minus 30. 15 minus 35 minus 20. 25 minus 35 minus 10. 35 minus 35, 0, 10, and 20. Add this together. This is minus 3. No need to add actually, you can skip adding. Now, D into F. D into F. So do it. Minus 150, minus 200, minus 250, 0, 200, and 200. So if you add these together, you will get minus 200. Put it in this formula. So A, my assumed mean was 35. Summation frequency into D, that was minus 200. And sum of frequency, we already found this as 100. This will give me 35 minus 2, which means 30. So you are getting exactly the same answer. On what basis we select the midpoint? And no basis. Just any center value. I mean, instead of A being the, instead of 35 being the assumed mean, you could have solved using 25 being the assumed mean. You'll get the same answer. So no, there is no selection criteria, just any center value. जो ऊपर और नीचे थोड़ा half दिखे, you select that value, right? So therefore, we can say that here also we notice that the answer is coming 33. Method number 3. Step deviation method. Now what will be x bar beta? A plus summation f d dash upon summation f into h, where h is your common factor. h is your common factor. हाँ? तो अब क्या करना है कि जहां पे हमने ये d निकाला है, we don't have to stop at d. हमें एक d dash निकालना होगा. So I'll remove this and we'll find d dash. What is this d dash? d divided by some common factor. जैसे यहाँ पे 10 कॉमन दिख रहा है, -30, -20, -10, 10, 20. Everything is divisible by 10. So you get -3, -2, -1, 0, 1 and 2. Now you multiply this d dash with frequency. So you will get 5 into -3, 10 into -2, 25 into -1. Right. Finish this 0, 20 and 20. Add this together. Check, you should get the same answer. -20, absolutely. -20, put it here. So A was 35 plus -20, sum of frequency was 100 and my common factor was 10. So I will get 35 minus 2, 33. So these are the different methods which you can use with different data sets. Very, very easy, very basic. Just I was brushing up what mean is. Okay. Mathematical properties. Okay. So whenever we find sum of deviation from mean, it is always 0. माने अगर हर ऑब्जर्वेशन का हमने मीन से डिविएशन निकाला और उसको हमने ऐड किया तो ये हमेशा 0 आएगा. टेक एन एग्जाम्पल. सपोज आई गो अहेड why not d into f by 10? Because we have found out d dash, right? We divided it by 10. And then we later multiply it back. So whatever you divide earlier, you multiply it back later on, if that's the question. Is that the question? If data is not continuous, we can. That is what we did. If data is not continuous, it is discrete. We already found out for discrete, na? That was the starting point. Either data will be discrete or continuous. For discrete, we saw how to find the mean. For continuous, we saw how to find the mean. So we are multiplying with 10 because earlier we divided the data by 10. Okay. What is deviation? Deviation means the difference that I find. Like this was a deviation. You found out the difference between two things, right? So deviation means the difference of observation from mean. So let's see this. So for example, I tell you that I have 3 data points. X is 1, 2, and 3. Now, if you find the mean of this data set, it will be 1 plus 2 plus 3 divided by 3. You will get 2. So if I find xi minus 2, what will I get? 1 minus 2, 2 minus 2, 3 minus 2, minus 1, 0, 1. And if I add this together, I am getting the answer as 0. That is what the property is saying. That if you sum the deviations from mean, जो भी x's है उनको mean से subtract करके उनको add कर दो, that will always be 0. That will always be 0. Right? Let us go ahead and let us try to prove this. Very simple proof. So beta, summation xi minus x bar can be written as summation xi minus summation x bar. It can be written as summation xi minus summation x bar. ये जो sum है इसको हमने individually इन दोनों के साथ लिखा है. Now we know that x bar is summation x by n. So summation x can be written as n into x bar. I can take this here. So instead of summation x, I can write n x bar minus summation x bar. And this summation x bar means that x bar is getting summed up n times. Tell me something, huh? Suppose I ask you what is 1 plus 1. Can you write this as 1 getting summed up 2 times? So 1 into 2 लिख सकते हो. If I ask you what is 1 plus 1 plus 1. So 1 is getting summed up 3 times. So you can write this as 1 into 3. If I ask you what is 1 plus 1 n times. So you can write this as n into 1. जितनी बारी 1 sum up होगा उतने से ही तो you are multiplying 1 into 2, 1 into 3, 1 into n. Now if here mean is getting summed up n times, can I write this as n into mean? Mean तो कोई एक number होगा and उसको आप n times add कर रहे हो. You're adding that n times. So you can write that as n into mean. So this will become n into mean minus n into mean, which means it will give you 0. So we have proved that summation xi minus x bar is 0. (10 to 20, 25 to 30). Then you find the midpoints accordingly. Not an issue. Use the same method. Whatever method we have done, you just use the same method. Okay, so this is the first property and one of the most important properties. Many times asked in CU8 exam as is. That the sum of deviation from mean is 0, 1, 2, minus 1. ऐसे करके कुछ numbers दे देंगे. So sum of deviation from mean is always 0. Second step, yes. So I have done nothing. So this was summation xi minus x bar. So whenever you have something like this, if I say summation a plus b, suppose, you can write this as summation a plus summation b. If I tell you summation xi minus x bar, you can write this as summation xi minus summation x bar. You can take sum individually. Now, I have replaced this summation xi because I know that the formula of mean is summation xi by n. So if I take this n here, I'll get summation xi as n into x bar. तो ये इसकी जगह पे I've got n into x bar. Okay, it is done here, n into x bar. So you get n into x bar minus summation x bar. So x bar is getting summed up n times. You get this as n into x bar and hence 0. Okay. Now let's go ahead and let's take the second property. Second property. The sum of squared deviation from mean, or the sum of squared deviation is minimum when taken from mean. Is minimum when taken from mean. To understand what I am saying. Suppose in exam they tell you कि मुझे submission xi minus a के whole square को minimize करना है. I have to minimize this. I have to minimize this value. Summation xi minus a whole square. तो question is कि what a should I take? ऐसा मैं क्या a लूं कि xi minus a whole square minimize हो जाए? The answer is that you should take the deviation from mean. जब आप mean से deviation लेके square करके add करते हो, वो आपको सबसे कम वैल्यू देता है as compared to doing it from any other number. आप a को कोई भी और number ले लो. Right? So for example, go back to the data set. Suppose I tell you x is 1, 2 and 3. ठीक है. And I am asking you कि मुझे xi को किसी एक नंबर से सब्ट्रैक्ट करके स्क्वायर करके ऐड करके मिनिमाइज करना है. आई नीड टू मिनिमाइज दिस. तो वो क्या एक ऐसा नंबर हो सकता है दैट दिस गिव्स मी द मिनिमम वैल्यू? शुड ए बी मीन? शुड ए बी मीडियन? शुड ए बी मोड? कौन सा ऐसा वैल्यू लूं दैट दिस इज मिनिमाइज्ड? So answer is that you should be finding deviation from mean, right? You should be finding deviation from mean. Let us try to go ahead and prove this thing. इसको prove करने का कोशिश करते हैं. So I want to minimize submission xi minus a whole square. बेटा minimize कैसे होता है? How do you minimize anything? The first order condition is you differentiate that function and you equate it to 0. आप उसको differentiate करके equal to 0 कर दो. This is the first order condition. So if I try to differentiate this function, अगर मैं इसको differentiate करूं with respect to a, तो कैसे differentiation होगा? How will differentiation happen? Power comes down. Summation xi minus a into 0 minus 1. I have used chain rule. So power comes down into this function into differentiation of this function with respect to a equal to 0. So I will get minus 2 summation xi minus a equal to 0. Minus 2 to constant, it can go on other side and become 0. So you get summation xi minus a equal to 0. So you get summation xi minus summation a equal to 0. अब देखो यहाँ पे n is getting added up n times. a plus a plus a plus a and so on. इसको I can write summation xi minus n times a equal to 0. Summation xi equal to na. A is equal to summation xi by n equal to mean. तो मेरा first order condition से आ गया. We have got that the value of a is equal to mean. Second order you can check on your own. So we have got that when A is X bar, then this value will be minimum. तब इसका value minimum होगा. Right. Very important property. Okay, I'll zoom out. So what this property is saying, let me repeat it, that the sum of squared deviation is minimum when taken from mean. ठीक है, अगर मुझे इस वैल्यू को मिनिमाइज करना है, if I have to minimize summation xi minus a whole square, तो वो किससे मैं deviation निकालूं? What should a be such that this is coming out to be minimum? That a should be the mean. That a should be the mean. Second order condition, very simple, just differentiate this again. Differentiate this again. So differentiation of x will be 0 and so I'll differentiate at this level, because I need to consider -1 also. So differentiation of x will be 0. Differentiation of a will be 1 and this will be -1 will come as is, right, and summed up. So you will get answer as plus n, which is greater than 0, therefore minimum. This differentiation is 0. Differentiation of a is -1. There is a -1 here and there is some outside, right? So this gives you summation of 1. 1 is getting summed up n times, so n, which is positive. Second order condition, positive means minimum. How do we use this property? In exam, they'll ask you application of these properties. So for example, if I asked you, consider data 3, 4, 5, 6. Find the value of minimized sum of squared deviation. And they give you some option. You have to find the minimum value of sum of squared deviation. So now I know कि वो minimum कब होगा? वो minimum तब होगा जब हम deviation mean से निकालेंगे, right? So what I will do is I will find the mean. 3 plus 4 plus 5 plus 6 divided by 4. Okay, you'll get some number. So this is 10, 15, 16, 17, 18 by 4, 4.5. And you'll find the deviation from mean. So you'll do 3 minus 4.5 square plus 4 minus 4.5 square plus 5 minus 4.5 square plus 6 minus 4.5 square, and you'll get the answer. But how do I know कि किससे deviation निकालें? Right? The word used is minimum. And it is minimum when I find deviation from mean. So I know that I have to deviate them from mean. That is how you can use the property. Okay. Property number 3. So mean, so if you're given two groups, group 1 and group 2, and I have to find joined mean, then this is group 1 frequency into mean of group 1, group 2 into mean of group 2 upon the sum of frequencies. Proofs not important. I am just proving to give you an intuition. So let me give you an example of this. So suppose in exam, you are given that the mean height of male students is say 61. And 61 centimeter. And the mean height of female students, so that is 58 centimeter. And there are 25 males and 35 females. They're asking you find the, no, these are very simple proofs, definitely not coming in ISI. Scroll up. Done. No, as I said, these are very, very simple proof. ISI does not ask these easy proofs. I will tell you what kind of proof will come there. Not such easy proofs. Huh? These are very simple class 8th, 9th, 10th proofs. Okay, so just think here. Huh? So we are saying that this is the mean, joint mean. So I've told you that there are 25 males, unka average height 61 hai. 35 females and unka average height 58 hai. I am asking what is the average height of all people together? Joint average height, combined average height. So it will be x12, right? And you can use this as, so number of males 25 into their average 61, female 35 into their average 58 upon 25 plus 35. Just find this value. Just write this in the chat. 59.25. Okay. So it will be 59.35. This is your joint average. Okay, good. Fine. So now that we have done this, let's talk about weighted mean. But you can use practice problems of NCERT also for this topic, huh? There are good questions in NCERT that you can use for this topic. Yes, that's right. You can call this as combined mean. Although I will be posting a lot of DPPs. I mean, you don't need to, but if you ever want to, you can also practice from NCERT. Okay, weighted mean. Weighted mean is when I want to provide some weightage to different observations. Okay? Usually used in index numbers. जैसे for example, अगर मुझे हर क्वांटिटी को प्राइस का वेटेज देना है, राइट? या अगर मुझे चाहिए कि I want to, maybe I'm finding some average, right? But I think I need to give weightage to people based on their height, or weightage to people based on their amount contributed in the family. Because if I think there are 3 members in the family and I want to give weightage to them based on how much money they're contributing in the family. So weightage can be anything, right? Any number. Then I will be using weighted mean. So when I talk about weighted mean, you will be provided with the weights, right? So the formula instead of frequency will be summation weightage into x by summation weightage. You will be given some weightage, right? For example, if I tell you that these are the wages of male, female and children, 40, 32 and 15, right? And I tell you that I have to give some weight I have to give a weightage of 20, 15, and 5. And I ask you find the weighted mean. So very simple. You just do W into X, 800, 32 into 15, 480, and 75. You add this together, 1355, and then you add the weights together. Right. So weighted mean will become 1355 divided by 40. Right. So it can be 33.88 approximately. Use calculator, huh? Even I keep my calculator open in front of me. Always use calculator to find the answers. So this is your weighted mean. Okay. Now, just one thing I want to highlight here, that if no weights are provided, it is automatically an implication that you have equal weightage for all individuals. If no weight is provided, it means you will have equal weightage to all individuals. What is the meaning of assigning weightage? So weightage means that sometimes I want to give different importance to different people. When I want to do that, that is when I will give weightage. So for example, if I think that men are contributing more to GDP as women, and I want to give them more weightage to inflate my GDP, probably I can give them a higher weightage. Weightage just is a way to give different importance to different categories. Right. So if they don't give you weight, then that means you're giving equal weightage, right? Everyone has equal weightage. In that case, there is no difference between arithmetic mean and weighted mean. So अगर ये weightage नहीं दिया होता, माने तीनों का weightage 1, 1, 1 होता, तो उस केस में if you find weighted mean, you will get same as arithmetic mean, right? So when no weightage is given, you assume that it is equal weightage of 1, 1, 1 to all three individuals. Now I have a question for all of you. So think through it, huh? Which of the following statement, one second, which of the following statement is true? A. If greater weight is assigned to greater value, simple arithmetic mean is less than weighted arithmetic mean. If greater weight is assigned to lower value, simple arithmetic mean is more than weighted average mean. You have to just tell me whether these statements are true or false. That would be easy. Take 1 minute, try to solve this. Think. Okay, good. Most of you have answered it correctly. So in order to understand this, we can go ahead and we can take a very simple example. Okay. Whenever in doubt in exam, take an example. वो सबसे आसान तरीका है solve करने का. So suppose if I tell you that my data set is 1, 2, 3. What will be simple arithmetic mean? It will be 2. Now what I do is I assign some weights. So what I will do is my observation is 1, 2, 3. And I have to assign some weight. So highest weightage to the highest number. क्या लिखा है? Greater weight assigned to greater value. So जैसे I assign a weightage of 3 here, 2 here and 1 here. So what will be the mean now? X into W, 1, 4, 9. Add this up, 14. So weighted arithmetic mean will be 14 divided by 3, 4, 5, 6. 14 divided by 6. So you'll get 2.12, 20, 18, 2.3 approximately. So weighted average mean will be more than simple average mean. Now, let me go ahead and let me do this. So now what I am doing is the following. X is 1, 2, 3 and greater weight is assigned to lower value. तो मैंने 1 को weight दे दिया 3 का, इसको दिया 2 का, इसको दिया 1 का. This is my weight. कम value को ज़्यादा weight, ज़्यादा value को कम weight. So what will be X into W? So it will be 3, 4, 3. It means it is going to be 10. So what will be weighted average mean? 10 divided by 3, 4, 5, 6. So what will this be? 1.40. 36 is 6. 1.6. Which is less than simple average mean, which was 2. Right? So when I assign greater weight to lower values, कम वैल्यू को ज्यादा वेट एंड ज्यादा वैल्यू को कम वेट, तो जो वेटेड एवरेज मीन है वो सिंपल एवरेज मीन से कम आ रहा है. एंड व्हेन आई असाइन मोर वेटेज टू मोर एंड लेस वेटेज टू लेस, तो वेटेड एवरेज मीन जो है वो SAM से ज्यादा आ रहा है. राइट? सो बोथ द स्टेटमेंट्स आर ट्रू स्टेटमेंट्स. बोथ A and B are true. Okay? Any doubt in this? Okay, I'll take 10-15 minutes more. So let's talk about median now. So median is defined as the middle value of the distribution. It's defined as the center value of the distribution. Okay. You can convert them in decimal. So 60% is 0.6, 80% is 0.8. Convert percentage in decimal. Make that into a number. No, not really, because, I mean, you can make that because weights are just like frequency, right? So you can use a step deviation or shortcut method also, but it's just, I mean, one of the implications of the SAM, of the simple method, right? Simple arithmetic mean. So if I just consider the weights like frequency, so very well I can just use any other method also. So I'll continue. So median is the center value or the middle value of the distribution. So what we notice is that if this is median, then 50% of the data will be here and 50% of the data will be here. Right? So it's also called as positional average. Right? Positional average, why? Because it is placement. In series. It's telling where exactly is the data lying. So it's a positional average in that sense. Okay. Now, again, we have three kind of data. So the first kind of data that I have, that I want to work with, is your individual data. In case of individual data, in median, we have two formulas. If the number of data is odd, if n is odd, then it will be n plus 1 by 2th observation. And if n is even, then it will be n by 2 plus n by 2 plus 1th observation divided by 2. Divided by 2. Let's try and find the median. So example, find median. You're given 900, 950, 1020, 1200, 1280. Step 1. Arrange data in ascending order. Means from lowest to highest. You have to arrange the data in the ascending order. Right? So, if we go ahead and if we do that, right? What if we give a weightage of 10 to 1 in the previous question? You can, doesn't matter. But to prove any statement as false or true, I am using just one example, right? One example will suffice, right? Okay. So no issues. You can try it with this. I mean, if you want to give 10, just give 10. So 10 into 1 will become 10. So this will become 10, 14, 15, 16, 17. And the sum of weights will become 13. So this will become 17 by 13, which is still less than 2. It doesn't matter. Any one example is fine. Right? Okay. So find the median. So step 1 is you arrange data in ascending order. And then step 2, since the number of observation is 5, which is odd, my median will be 5 plus 1 by 2th observation. 5 plus 1 means 6 by 2. That means third observation. It will be third observation. So you look at the third observation. So your median will be 1020. This becomes your median. 1020. Okay, now try this one. So I'm giving you this to try. Find median, all of you. 900, 950, 1020, 1200, 1280, 1300. Find median. Find median. So first arrange it in ascending order. Ascending में ही है, कम से ज्यादा ही जा रहा है. So step 1 is already done for you. Step 2 क्या होगा? What is n? N is 6. So the number of observations that we have, that is even, right? So how do I find median? N by 2, that means 6 by 2th observation plus 6 by 2 plus 1th observation divided by 2. 6 by 2 माने third observation. 6 by 2 plus 1. So 3 plus 1. Fourth observation by 2. Third observation. Fourth observation by 2. Right. So you will get 2, 2, 2, 0 by 2. 1, 1, 1, 0. 1, 1, 1, 0. So here I want to highlight that median is not affected by extreme values, but mean is. Median is not affected by extreme value, but mean is. माने बेटा whether this is 1300, अगर ये 1300 है या ये 13,000 है या ये 1,30,000 है, इससे मीडियन को कोई फर्क ही नहीं पड़ेगा. बिकॉज मीडियन तो सिर्फ थर्ड एंड फोर्थ ऑब्जर्वेशन की वजह से निकल पा रहे थे. लास्ट का एक्सट्रीम वैल्यू 1,30,000 है या 13,000 है या 1,300 है, इट विल नॉट अफेक्ट द मीडियन. सिमिलरली फर्स्ट ऑब्जर्वेशन 900 है या 90 है या 9 है, it will not affect median. Median is only concerned with center. So extreme values, outliers, outliers मतलब जो डेटा से बहुत अलग values दिखें, the values which don't look very similar to other data points. जैसे सारा data points 900 से 1000 के बीच में है, 1200 के बीच में है, right? Suppose this is also 1300, but this is 9. So 9 is not looking very close to other data points. This is an outlier. This will not affect median. इससे median को कोई फर्क नहीं पड़ेगा. It will not affect median. But it will affect mean. Because mean will consider all the data points. Mean सारा data लेता है. तो क्योंकि mean सारा data लेता है, because it takes all data into consideration, mean will be affected. But median will not be affected, right? Okay. Now, let's write down for the next data set. The next data set is when frequency is given. So, second, with frequency, but discrete, right? So if you are given frequency, then the formula of median is same. But now we have to go ahead and we have to find something which is called as cumulative frequency beta. We have to find cumulative frequency. And cumulative means what? So cumulative frequency. How can we find cumulative frequency? We can find cumulative frequency by adding the previous frequencies. Right? So let's take an example. Let's say you are given some individuals and their income. So you're given individual, their income is 800, 1000, 1500, 1800, 2000, 2500. And I ask you, I've given you the frequency and I ask you it is 16, 24, 26, 30, Let me write it properly. It's causing confusion. 16, 24, 26, 30, 20, and 6. Right. Now, the first thing that we do, this is called as a data, discrete data, but with frequency distribution. Right. Now, in such cases, whenever you have this case, you should first find out something which is known as cumulative frequency. So CF. And how do we find that? By adding previous frequencies together. So iske previous to kuch nahi hai, so 16. This will be 24 plus 16. So it will be 40. This will be 26 plus 40. So this will be 66. Right? This will be 66 plus 30. So 96. 96 plus 20, 116. 116 plus 6, 122. This is how you can find cumulative frequency. This last number, जो ये आखिरी number आएगा, it should always be the sum of the frequency. ये हमेशा same होना चाहिए. Both these will be exactly same. Right? So now, once you go ahead and you find cumulative frequency, you have to just use a simple formula, which can be, so write down, median is going to be cumulative frequency plus 1 by 2th observation. So it means 122 plus 1 by 2, 123 by 2, 61.5th observation. So you will look for that income class whose cumulative frequency is 61.5, closest to 61.5. Right? So you will notice that it is happening here. So it means that your median class or median here will be 1500. That will be your median. Right? Any doubt in this? Always look for a higher number. माने अगर यहाँ पे 60 भी होता तो हम 60 नहीं लेते, हम 61.5 से ज्यादा वाला लेंगे हमेशा. Right? So we will look for something which is more than 61.5. Okay. Now, if you look here, the number of observations I had, 1, 2, 3, 4, 5, 6. The number of observations that I had, they were 6, right? Some books, they suggest that for such cases, जहां पे आपको frequency दी होती है, वहां पे भी you should apply this formula. You can apply this formula. बस N को you can replace with CF, but it's not required. This will give you exactly correct answer. You just have to use this formula irrespective of this. Whether it is total number is odd or even, you just use directly this formula and you will get the right answer. इसमें odd even करने की जरूरत नहीं है. You don't have to do odd or even here. It makes no sense here. Okay. So take a question, try to find the median here, all of you quickly. So you're given that the data point is 2, 4, 6, 8. You're given frequency as 3, 5, 4, 2. Find median. All of you, do it quickly. I'll add some merits and demerits of each median, mode, and mean. Read that subjective part also. Okay, all of you are right. So let's quickly do it. So cumulative frequency will be 3, 3 plus 5, 8, 8 plus 4, 12, 12 plus 2, 14. So 14 plus 1 by 2th observation, 15 by 2, 7.5. It lies here. So median will be 4. Median will be 4. Correct. Okay. Continuous data. For continuous data, the median is L plus N by 2 minus CF by F into I. Please write down with me very carefully, beta. Cumulative frequency is of preceding class. Right. Frequency is of current class. I is the size of interval. L is the lower limit of interval. L is the lower limit of the interval. Let me give you an example. How to solve. Marks are given to you 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50. We're given some frequency. Right? 7, 15, 24, 31, 42, 30, 26, 15, and 10. This data is given. Okay. Now, look here. First of all, I understand that I need cumulative frequency. So, मैं एक बारी वो निकाल देती हूँ. Cumulative frequency. Add the frequencies together. 7, 22, 22 plus 24, 46. Just fill in this. 77, 119, plus 30, 149, plus 26, 175, plus 15, 190, plus 10, 200. Step 1, you will find cumulative frequency. Step 2, find n by 2. n means total of the frequency. So I told you कि ये वाला number हमेशा यही आएगा. So this will also be 200. So total number of observation is 200. Divided by 2, you will get 100. Right. Find class interval where CF is close to 100 but more than 100. Where CF is close to 100 but more than 100. आपको ऐसा क्लास इंटरवल निकालना है जहां पे क्यूमुलेटिव फ्रीक्वेंसी 100 के पास तो हो पर 100 से ज्यादा हो. So it is going to be this. ठीक है. Now plug it in this formula. इस formula में plug in करो. So इस class interval के लिए what is the lower limit बेटा? It is 25. What is n by 2? वो तो हमने वैसे ही निकाला हुआ है 100. CF of the preceding class. So cumulative frequency preceding class का कितना है? 77. Frequency of the current class. Current class का frequency कितना है? 42. Into size of class interval. What is the size? What is the gap? 5. Just find the answer. Tell me if there is any doubt in this formula. Any doubt in this formula? $27.73. Okay. Okay. Any doubt? Anyone? Why CF has 77 and not 190? You take cumulative frequency of the preceding class, right? So preceding class is 77. Anything else? CF always before the median class. Cumulative frequency of the median class नहीं, उसके पहले वाले तक का. In a way, just try to think intuitively. Out of n by 2, we are subtracting the earlier frequencies. हम पुराने वाले को subtract कर रहे हैं एक तरीके से. पुराने सारी observation को subtract कर रहे हैं. Why do we take more than 100 class specifically? Because n by 2 here is 100 now. That is why 100 is coming here. So ideally it is find class interval where cumulative frequency is closer to n by 2. In this case, n by 2 is 100, but more than n by 2. 100 is not fixed. What is meant by placement in series? Placement means position. Where do you stand in series? Right? So for example, very simple. Suppose if I tell you that my series is 1, 2, 3, 4, 5. Then my median is this observation. This is having 50% here and 50% here. It will be 3. But if my series is 1, 1.1, 1.5, 1.8 and 2, right? Or यहाँ पे 3 ही दे देते हैं, and 3. Then my median becomes 1.5. So when the position of 3 changed, it no more was the median, right? So it depends on which data is splitting it into 50-50 each. That is the meaning of placement. It's a positional average. It depends on position. What if there were 99 and 119? Yeah, then also you would have taken 119. Always take more than n by 2. Always color the class which is more than n by 2. What if it was a CF of 100 instead of 77? Then also you take 119. Always take more than n by 2. Not equal, more than n by 2. What's the difference between mean and median? Mean is giving you an average. So average means that it is going ahead and saying that if I take all observations, तो उसका average कितना होगा? What is that number which considers all observations together and helps me understand a number which is giving me average. Median is not doing that. First of all, median is not taking all the observation. Median is just telling me which is that number such that 50% of the numbers lie below and 50% lie above. Right? So it is that observation कि इससे देखो, there are total 5 observations. तो ये ऐसी एक ऑब्जर्वेशन होनी चाहिए कि 2 ऑब्जर्वेशन इसके नीचे हों और 2 इसके ऊपर हों. उन ऑब्जर्वेशन का वैल्यू कितना है डज नॉट मैटर टू मी, राइट? ये ऑब्जर्वेशन 3 भी हो सकती है, 8 भी हो सकती है, 20 भी हो सकती है, डज नॉट मैटर. बट दिस ऑब्जर्वेशन दैट आई हैव सेड दैट इज द मीडियन is such that 50% is here and 50% is here. If n by 2 was 60, then we would have taken 20 to 25 interval. Yes, that's right. In the previous type of data set, instead of taking cumulative frequency, we can take the sum of frequency. That's right. You can do that. Why we are not doing n plus 1 by 2? As I said, when you move from discrete towards other, it does not really matter whether you do n or n plus 1. So the general formula is always with n by 2. Right? Even if you would have done n plus 1 by 2, it would not have really mattered, right? In this case, you would have still marked the same class. So generally, we always mark n by 2. If n by 2 is 119, then you take the next class. You always take greater than. Close but more. Okay. Now, for median, there are some additional positional measures also. One of them is called as quartile. One is called as decile. And one is called as percentile. So median was doing what? Median was that observation such that 50% was here and 50% was here. Quartile is that observation. It is coming from the word quarter. And how many quarters are there? 4. तो जो डेटा को 4 पार्ट्स में डिवाइड करे, 1, 2, 3 and 4. Right? So when data is divided in 4 equal parts, then it is quartile. If data is divided in 10 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you divide it in 10 parts, right, then it is decile. If you divide it in 100 parts, then percentile, right? So in such cases, in such kind of questions, whenever you have to find quartile or percentile और decile, ऐसा कुछ भी निकालना है, तो मीडियन से बहुत सिमिलर फॉर्मूला ही रहता है, but you just have to go ahead and take 4 everywhere. So I'll start with quartile. बाकी क्या I will leave it to you. You do it yourself. Yes, percentile is 100 parts of the data set. अब ध्यान से देखना. So I'm telling you about quartile, huh? So let's say in quartile, this is called Q1, this is called Q2, and this is called Q3. यहाँ पे I have 1/4 of the data set. Plus, फिर यहाँ पे भी I have 1/4 of the data set. यहाँ पे again I have another 1/4 of the data set. And यहाँ पे I have remaining 1/4 of the data set. So it means that when I find this value, जब मैं ये वाला value निकालती हूँ, Q1, तो इसका रेशियो रहता है कि 1/4 डेटा यहाँ पे रहा होगा and 3/4 would have been here. When I find Q2, it means that here I would have had 1/4 plus 1/4. It means 2/4. 2/4 means half of the data set, and half would have been here. And when I find Q3, it means I would have had 3/4 of the data here and 1/4 here. Right? So we can go ahead and we can say that Q1 के केस में 1/4 यहाँ पे है और remaining 3/4 पीछे है. Q2 के केस में 2/4 यहाँ पे है और 2/4 बाद में है. तो 2/4 is nothing but half. 2/4 is 1/2. माने Q2 जो होगा, it is nothing but median also. क्योंकि half of the data set is here and half of the data set is here. So we can say that Q2 and median will be the same thing. एक ही बात है, Q2 निकाल लो या median निकाल लो, क्योंकि half यहाँ पे और half यहाँ. Q3 is where 3/4 of the data is here and remaining 1/4 is here. Right. So if I have to find Q1, like हम median में कर रहे थे, n/2 या n+1/2 कर रहे थे, so यहाँ पे क्योंकि we are splitting it in 4 parts, Q1 will become n+1/4th term. Q2 will become 2/4 n+1th term. Q3 will become 3/4. इसको I can write 1/4. Huh? It will be easy. n+1/2. Right? So basically, when we talk about quartile, जब हम quartile की बात करते हैं, quartile में we are dividing the data in your 4 parts, 4 equal parts, right? So since we are dividing the data in 4 equal parts, therefore you have n+1/4th term, 2/4 n+1th term, 3/4 n+1th term. Is it clear? You're using 4 here. So, for example, if I ask you, find Q1, Q2, Q3 for the following data. 5, 7, 8, 12, 13, 16, 18, 21. Just try this. What's the purpose of splitting in 4 parts? Just for better understanding of the data set, nothing else. So if I want to understand more about the data set, how my data is looking, I may understand it using quartile. Usually, if you look into, you're economic student, so if you look into income inequality, if you look into income distribution, their quartile can be useful. जैसे अगर कोई मेरे से पूछे कि हमारे इंडिया में bottom 25% income कितना है, what is that level जो bottom 25% को represent करता है, and I tell you that the income level is suppose ₹120 per day, माने इसके नीचे 1/4 of the लोग, 1/4 of the population, they live below 120 per day, right? So bottom 25%, top 25%, these all things can be found out using quartile. Bottom 25% means what? I'm finding Q1. Top 25% means what? I am finding Q4, right? So there I can use as an economist quartile. But I just took 1.5 hour lecture yesterday on strategy. I'm going to take another one soon, but I hope that for few days we are done with the strategy questions. Okay, so find out Q1. Okay, good all of you, huh? So when you find Q1, right, it will be, all of you have answered it, but I want to show you once how to find Q1, then you do it on your own, okay? So Q1 के लिए I find out n plus 1 by 4. Just do n plus 1 by 4. And then there is no odd even in quartile, decile and percentile. n by जैसे वहां पर दो अलग फॉर्मूला थे ऑड और इवन के, ऐसा कुछ नहीं है यहाँ पे. तो यहाँ पे हमें क्या करना है, ध्यान से समझो. 1 2 3 4 5 6 7 8. 8 plus 1 by 4, 9 by 4th term. बहुत ध्यान से सुनना है. Listen to me very carefully. 9 by 4 will come out as 2.25th term. 2.25th term. अब हम क्या करेंगे इसको? What will we do it? In such cases, जब भी you get a decimal, listen to me very, very, very carefully. Whenever you get a decimal, you will split it. And how do you split it? 2.25 को आप लिखोगे second term plus 0.25 third minus second term. Second term plus 0.25 third minus second term. तो ये हो जाएगा second term means what? 7 plus 0.25, 8 minus 7. Answer will be 7.25. This will be your quartile. This will be your quartile. First quartile. Very important. In quartile, percentile, decile, there is no separate formula for odd even. You do it like this. अब इसी तरीके से if you ask me, ma'am, what is Q3? तो Q3 क्या था बेटा? 3 by 4 n plus 1th term. It means 3 by 4. What is n? N is 8 plus 1th term. It means 9 into 3, 27 by 4th term. 27 by 4th term. So 27 by 4 karo. Just do it. What is it going to be? Tell me what 27 by 4 will be. 6 point. Yes, 6.75. 6.75 टर्म का मतलब हो गया, इसको स्प्लिट करेंगे. सो इट विल बी 6th टर्म प्लस 0.75 ऑफ 7th minus 6th term. So it is going to be 6th term. So 1, 2, 3, 4, 5, 6, 16 plus 0.75, 18 minus 16. जो भी आंसर है, whatever answer you get. 17.5. Okay. ठीक है. So we'll stop here for today. Take a homework question here. For the same data that I have shared with you, find first 9th decile, find 10th 60th percentile. First and 9th decile, 10th and 60th percentile. तो क्या करना होगा? Decile माने what? 10 parts. तो first decile होगा 1 by 10 n plus 1th term. 9th decile होगा 9 by 10 n plus 1th term. Percentile means 100 part. तो 10th percentile होगा 10 by 100 n plus 1th term. 60th percentile होगा 60 by 100 n plus 1th term. If I ask you find 40th percentile, कुछ नहीं, 40 by 100, n plus 1th term. Simple. जो भी निकालना है, अगर डिसाइल निकालना है, डिनोमिनेटर विल बी 10 और न्यूमरेटर जो भी डिसाइल निकालना है. सो फर्स्ट डिसाइल 1 by 10, 9th डिसाइल 9 by 10, 10th percentile 10 by 100, 60th percentile 60 by 100, 40th percentile 40 by 100, third quartile 3 by 4, first quartile 1 by 4. क्वार्टाइल का मीनिंग है यू डिवाइड बाय 4. थर्ड निकालना है तो यू मल्टीप्लाई विद 3. फर्स्ट क्वार्टाइल था, यू डिवाइड बाय 4, यू मल्टीप्लाई बाय 1. राइट? सो दिस इज हाउ यू कैन पुट एनी फॉर्मूला. You can make any formula that you want to. Similar is the case for Q2 also. Yes. Okay. So that is it. We'll stop here for today.
Number which divides your given data set in exactly 2 equal parts. So please write down, it is positional number which divides given series into 2 equal parts. Exactly 2 equal parts में अगर करे कोई चीज तो वो median है. जैसे for example, but if I say 1, 4, 5, 7, 8. So median will be any number on the third position. Because there will be 2 numbers below and 2 numbers above. So median will simply be any number on the third position. I say for example, let's say I have the data set 11, 13, randomly take numbers 14, 17, 18, 19, 20. Then beta, this number, if I look at this number, this will be my median. I have exactly 3 numbers below 17 and exactly 3 numbers after 17. So this 17 will act as a median to my data set. But what is the formula for median? Matlab, ऐसे तो just by inspection we don't want to do this. So in order to find the formula for any central tendency, we need to do it for 2 cases. The first is called as ungrouped data. So ungrouped data matlab ki kya? When my data is just scattered around like this, there are no classes that I have created. So in that case, I can have median depending on whether the number of observations are even or odd. So if my n is odd, then my median will be n plus 1 by 2th term. But whenever you will find median, you must arrange the data in ascending order and then try to find the median. So any observation which divides my data set exactly in 2 halves is the median. And here I am saying that if my n is odd, then I will find n plus 1th term. That term will be the median. And beta, if you have n as even, then it will be n by 2th term plus n by 2 plus 1th term divided by 2. So depending on whether you have even or odd, these are the 2 formulas that you will have. Now, beta, if your data set is in fact a grouped data set, then, or in other words, it is a continuous series that you have, then your median will be L plus H by F n by 2 minus C. So beta, L will be the lower limit of median class. H will be the width of median class. F will be the frequency of median class. Right, beta? N will be the total frequency. Okay, beta? And C will be the, so इसको बहुत books CF भी लिखती हैं. This is cumulative frequency. Of preceding class. Okay, बेटा. तो एक बार जरा एक एग्जाम्पल लेके देख लेते हैं. So यहीं से शुरू करते हैं. देखो that here my n is 5. I have 5 observations. These are already in ascending order, so I don't have to put them in the ascending order. So beta median will be n plus 1 by 2th observation. So since my n is 5, it will be 5 plus 1 by 2th observation. That means 6 by 2. That means third observation. So my third observation came out to be 5. So that becomes the median. Suppose, let's say that your data set was this. 1, 5, 7, 4, 8, and let's say 15. Something like this was your data set. So beta, first of all, I can see that there are 6 observations. So I have to use the formula of even data set. Secondly, I can see that this is not in ascending order. So I must first put this in the ascending order. So what will I do? I will put this in the ascending order 1, 4, 5, 7, 8, and 15. Now this is in the ascending order. And now what I will do? I will use the formula that I know for even series, which will be n by 2th observation plus n by 2 plus 1th observation divided by 2. So here, if you can see, I have n as 6. So beta, this will be 6 by 2th observation plus 6 by 2 plus 1th observation divided by 2. So 6 by 2 means 3. That means I am saying this will be third observation plus 6 by 2 is 3. 3 plus 1 is 4. So I will have beta fourth observation divided by 2. So my third observation is 5. My fourth observation is 7 divided by 2. So 12 by 2, that means 6. So median of this data set is 6, right? So median is any number that divides your data set in exactly 2 parts. So if I place a 6 here, then 3 numbers will come here and 3 here. That will be the median of my data set. So it is pretty simple to find the median of ungrouped data set. Now let us try to find it for a grouped data set. So take an example. Suppose I go ahead and so we can have a median which is not present in the data set. Yes, beta. A lot of times, whenever you have even data set, your median will never be present in the data set. That's correct, right? It's a lot of times it will also be a decimal. It should be a number which divides it into 2 equal parts. That's what the concept is. Okay, so let us go ahead and have the, let's say, age here. And my age can be 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. This is my age group that I have taken. Now, let us take some frequencies. I will just explain what is C beta. Just take a minute. It is cumulative frequency. Let me show you how to get that. So now what I will do is, we will take frequency. So frequency is given to you 8, 12, 10, 8, 3, 2, 7. इतना ही डेटा दिया होगा. And they're asking you find median. So the first thing that you have to do is find cumulative frequency, CF. This is what this is. Cumulative frequency. So cumulative frequency का क्या मतलब है? You will keep adding the preceding frequencies together. So beta, this will be 8. This will be 12 plus 8. That means 20. This will be 10 plus 12 plus 8. That means it will be 30. So till that level, you add all the preceding frequencies. So 38, then 41, 43, and 50. And so this is what you have got as cumulative frequency. Now, the first thing that you must be doing is you must be finding the median class. देखो हर चीज हमें किसके लिए निकालनी है? Lower limit of the median class, width of the median class, frequency of the median class. तो हर चीज तो median class के लिए निकालनी है ना? So the first thing that I need to do is find the median class. To do that, beta, we know that the sum of frequency will be 50. क्योंकि यहाँ पे 50 आ रहा है ना, तो इन सबको add करके मुझे 50 मिला होगा. Now, in order to find the median class, step 1, you will find n by 2. So beta, ये हो जाएगा 50 by 2. That means 25. ठीक है? Now, what will you do? You will go ahead and you will find where can you find CF just greater than n by 2. Where can you find CF, cumulative frequency, just greater than n by 2? तो ऐसा कहाँ हो रहा है जहां cumulative frequency greater than 25 रही होगी, just greater than 25? तो बेटा ये तो 8 है, ये तो नहीं हो सकता. ये 20 है, ये भी लेस है, ये 30 है, ये करेक्ट है. So you will get this as your median class. Right? So your median class will become as 20 to 30. अब बस फॉर्मूला में लगा दो. So median class हो गई 20 से 30. So 20 से 30 की लोअर लिमिट हो गई बेटा 20. Width of the median class. तो width मतलब कि लोअर लिमिट एंड अपर लिमिट का गैप. So the gap बेटा is 10. Frequency of the median class. बेटा median class की जो frequency आई है वो है 10. N, that means total frequency. Total frequency आई है 50. And cumulative frequency of the previous class. Median class से पहले वाले की cumulative frequency. माने cumulative frequency में एक ऊपर वाली लूंगी. So I will take that as 20. So beta, with this, I have got all my values with me. Just put it in the formula. So if I just put this in the formula, I will get 20 plus 10 by 50, not 50, 10, 50 by 2 minus 20. This is what you will get. So if you solve this, you will get 20 plus 5. That means 25. So your median will be 25. So the aim here is to identify the median class. If you can identify the median class, you can just simply go ahead and solve the question. Okay, beta, let us take the next question. Question number 2. So I am saying find the median. And now what I have done is I have written here marks less than. And here I've written 80, 70, 60, 50, 40, 30, 20, and 10. And I've given you the number of students here. So I've given you 100, 90, 80, 60, 32, 20, and then 13, and then 5. These are the number of students that you have. Better check that now the language is changed. So it is saying number of students who have scored less than 80. तो 80 से कम कितने बच्चों के आए हैं? 100 बच्चों के. और 70 से कम कितने बच्चों के आए हैं? 90 के. So बेटा 70 और 80 के बीच में कितने बच्चे रहे होंगे? 10. So now what you have to do is you have to try and change this data set such that you are able to get the class interval from this data set. So again, just think about it. I am saying that there are 5 students who have scored less than 10. And there are 20, there are 13 students who have scored less than 20. So beta 10 से 20 के बीच में कितने बच्चे रहे होंगे? 13 minus 5, that means 8. So there will be 8 students who have scored between 10 to 20 and 0 से 10 के बीच में 5. Similarly, just try and convert it. So when you see that marks less than 30, there are 20 students who have scored less than 30 and there are 13 students who have scored less than 20. तो बच्चे 20 से 30 के बीच में कितने रहे होंगे? 20 minus 13, that means 7. Just convert this entire data set in that aspect. So I will now have 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Between 0 to 10, I see that there are 5 people. Between 10 to 20, I see that there are 8 people. Between 20 to 30, there are 7 people. And similarly, you can just subtract and keep finding. So, if you see, then less than 40, there are 32 people, and less than 30, there are 20 people. So between them, there will be 12 people. So, इनको जब subtract करते जाओगे ना, you will keep getting how many people are there in that particular class. So by solving it, you will get a data set which looks like this. Beta, you have to practice these questions on the same day, please. This is your data set. Now, understand. Beta, everybody, all 100 students have scored less than 80. So total students to 100 हुए ना. So when you add this frequency together, you should get exactly 100. Because everybody has scored less than 80, all 100 students. So from that 100 only, I'm making this split. So when I add the frequency together, I should get back that 100. Now, we just have to find cumulative frequency. So, ये हो जाएगा 5, 13, 20, 32. बस add कर रहे हैं 60, 80, 90, and 100. अब median निकालो बेटा. So what will be n by 2? N by 2 will be 100 divided by 2. That means 50. Find the median class. Won't the CF be one given above? Yes, beta. That is exactly what the CF is. That is what I've written. 5, 13, 20, 32. Yahi CF hai. Correct. The same thing. Huh? So now just find n by 2. That will be 50. So 50 के लिए कौन सी ऐसी क्लास है such that it has its जो भी हम लोग उसकी frequency check करेंगे, it should be matching according to 50. So I want the cumulative frequency to be greater than exactly n by 2. So find out that class whose cumulative frequency is greater than 50. That will be this class, beta. Its cumulative frequency is greater than 50. So now I have got all values that my median class will be 40 to 50. Sometimes in MCQs, they will directly ask you median class. They won't go beyond that. ठीक है जी? तो अच्छा कभी-कभी क्या होता है ना? जैसे median class बेटा अगर 40 से 50 के बीच में है, इससे मुझे आइडिया मिल गया कि जो भी मेरा median होगा, it must lie between 40 to 50 because वही मेरी median class है. So supposedly they ask you to find the median and they have given you 4 options: 42, 57, 38, 26. Suppose ऐसे कोई options दिए हैं and they're asking you find the median. So beta, I know that my median class is 40 to 50. That means my median has to lie between 40 to 50. So I can simply eliminate these 3 options and say that the median will be 40. So you can also do this if there is only one option in the median class. Okay. अच्छा, सो मीडियन क्लास इज 40 to 50, सो L हो जाएगा 40 लोअर लिमिट, ठीक है। फ्रीक्वेंसी मीडियन क्लास की हो गई 28, क्लास की विड्थ हो गई 10, और क्यूमुलेटिव फ्रीक्वेंसी फॉर्मूला में लेते हैं ऑफ द प्रीवियस क्लास, सो प्रीवियस क्लास की क्यूमुलेटिव फ्रीक्वेंसी हो गई 32. जस्ट पुट दिस इन द फॉर्मूला and you should be able to get the median. So median will be 40 plus 10 by 28, 50 minus 32. Correct, beta. The median will be 46.4. That's the answer to your question. Okay. Now, we are going to go ahead and we are going to take one more question for the median, and I'm going to just tell you how to solve this. Then later you can just try to do it yourself. So let's say, beta, that you're given a question where the median data is not continuous. So for example, you're given, let's say, 92 to 97, 98 to 103, 104 to 100, let's say, not 103, let's say 102, 102 to, let's say, 108. ऐसा कुछ डेटा दिया हुआ है आपको. But this data set that is given to you is not continuous. You see that this is 97, then this starts from 98. This is 102, and then this suppose starts from 103. ऐसा कुछ data set दिया हुआ है. So whenever you are given a data set which is not continuous, before you calculate the median or even mean, you must convert this into a continuous data set. How do I convert this into a continuous data set? So what will you do is you will check the gap between these two. So the gap between two is 98 minus 97, that means 1. And you can go ahead and you can just find the average of the gap. That means it is going to be 0.5. That is going to be my average. What you will do is, from the upper limit, you're going to just add this, right? And from this lower limit, you can just subtract this. And you can convert this into a continuous data set. So what will happen is your data set will look like this: 92.5 to 97.5, 97.5 to 102.5, something like this, 102.5 to 107.5, suppose this is 7, and so on. So basically, if you have a discontinuous data set, you must first convert that into a continuous data set before you can go ahead and before you can solve it. That is what is important. Okay? Otherwise, the process is the same. Okay, so just a homework question before I go to mode. Please try and do this. So you're given sales and you're given frequency. You're given sale less than 10, less than 20, 30, 40, 50, 60. And you're given frequency 4, 20, 35, 55, 62, 67. Okay, ऐसा दिया हुआ है. The question is, find the median. Right? And I'm telling you that the answer that you should be getting, please verify, you should get median as 29. That should be your answer. Okay. Now what we will do is, we will go back to the characteristics that we had studied yesterday, beta. So if you remember the features that I had studied, the first feature was that it should be rigidly defined. This is what the first feature of median central tendency said. So the question is median rigidly defined? Yes, I have a fixed formula for median, so that is correct. But the second feature was that it should be easy to understand. Is median easy to understand? Yes, the formula is pretty simple. The third feature was better, it should be based on all observations. Is median based on all observations? No. देखो कैसे all observation पे based नहीं है, क्यों नहीं है? क्योंकि ध्यान से देखो कि ये ऑब्जर्वेशन बेटा, ये जो 8 है, अगर इस 8 को मैं 80 भी बना दूं, it does not matter. It is just based on the position. It does not matter what other observations come out to be. Suppose your observation minus 100 bhi hoti. It does not matter. My median will always be the third position because there are 5 observations. So it is not based on all observations. So we are going to go ahead and say that no, it is not based on all observations. Fourth, beta, is it suitable for further mathematical or statistical theory? So partially. Why partially? Because very rarely you will see median being used further. एक median deviation करके निकालते हैं, but otherwise you will not see median a lot. चाहे variance निकालना हो, चाहे standard deviation निकालना हो, या और कुछ भी hypothesis testing करना हो, most of the time everything is done on mean. A lot is not done on median, so it is not being used too much for the mathematical or statistical theory. Then beta, fifth, is it affected by outliers or sampling? Beta, it is not affected by outliers. It is not affected by outliers. क्यों? क्योंकि exactly this is what I explained you, that when you make this number very extreme also, suppose it's 80,000 bhi kar do, my median will still be 5. It is not being, it does not change by your extreme observations, right? So in fact, this is the best merit of median, that median is a positional average. It is not affected by extreme observation. इसको extreme observation से कोई फर्क नहीं पड़ता. पर disadvantage भी यही है कि वो हर observation को consider ही नहीं करता और सिर्फ कुछ observation को consider करता है. Right? One more thing which I wanted to highlight yesterday, beta, which we did, that median can also be calculated for qualitative data set. है ना? जैसे आप मेरे पास एक डेटा लेके आओ और आप बोलो कि मैम लोग मेरे पास ऐसे, I have 10 students. The first one has low IQ, low IQ, medium IQ, medium IQ, medium IQ, high IQ, high IQ. ऐसे करके आपने एक डेटा सेट दे दिया मुझे. Now you ask me, ma'am, what is the median of this data set? So I will just calculate observation 1, 2, 3, 4, 5, 6, 7. That means the one here is the median. There are 3 below this and 3 above this. So we can get some idea about the data set that 50% of the students have medium IQ. More, 50% have more than medium, 50% have less than medium. So median can still be used for finding some analysis even on the qualitative data set, which mean cannot be used. Many कह सकती on an average you have medium IQ. Now, I cannot talk about mean that way, but I can still do some analysis, some qualitative analysis using median. Okay, beta. Now, so when I talk about mode, what is mode? It is the value that occurs more frequently or most frequently in the data set. So जो भी वैल्यू सबसे ज्यादा फ्रीक्वेंटली आ रही होगी उस वैल्यू को हम मोड बोलेंगे. Now, beta, I can only, so there are multiple methods of mode. The first method that I'm going to teach you, I can only apply that method if I have a uni-model data set. So please write down number 1, uni-model data set. What do I mean by uni-model data set, beta? Uni-model means that there is only one observation with the highest frequency. Just an example. So I tell you that I have a data set 1, 2, 3, 4, and 5. And let's say I'm given frequency of each of this. So beta 1 की frequency दी हुई है 13, let's say 62, let's say 40, let's say 37, let's say 28. So we know that 2 occurs maximum number of times. There are 62 times that 2 is coming in the data set. So data set कुछ ऐसा रहा होगा. 1, 1, 1, 1, 1, 1, 13 times आ रहा होगा. फिर 2 आ रहा होगा, 2, 2, 2, 2, 2. ऐसे 262 times आ रहा होगा. फिर 3 आ रहा होगा 40 times and so on. So beta, because 2 is occurring the maximum number of times, we know 2 is the mode. But suppose यहाँ पर भी 62 होता, right? Up there are 2 observations with highest frequency. Then I cannot apply the usual way of finding mode. फिर मैं नहीं बोल सकती कि 2 and 4 are both mode of the class. No, I can't do that. So I can only say by looking into the data that that is the mode if it is a uni-model data set. If there is only one observation with highest frequency, only then I can apply that. Okay. So abhi ke liye, the first thing that I am starting with, I'm only working first of all with uni-model data sets beta. So let us take the formula now. So if you have grouped or continuous data set, ungrouped का तो simple है, जिसकी highest frequency होगी वो mode हो गया. But if you have grouped data set, then beta mode will be L plus H F1 minus F0 upon F1 minus F0 plus F1 minus F2. This is the formula of mode. Let me write down all the meaning. So L is your lower class. Beta H is the width. F1 is the frequency of model class. F0 is the frequency of preceding class. And F2 is the frequency of succeeding class. Let us take an example. So supposedly, let's say that you have age given to you. And you have some frequency also given. So age is given as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. And beta, you're given some frequencies also. 8, 12, 10, 8, 3, and 2. सबसे पहले you will identify the model class. Model class मतलब कौन सी वो class है जिसकी highest frequency है. Which class has highest frequency? So as I can see, this is the class that has highest frequency. So this is called my model class. The frequency is 12 here, highest. Now just go ahead and try to apply the formula on this. So what will be my formula? L plus H F1 minus F0 upon F1 minus F0 plus F1 minus F2. So L, the lower one, is going to be 10. H, that means the width of the class, but this will be 10. F1 means the frequency of this class. This will be 12. F0 is the frequency of the preceding class. That means 8 upon 12 minus 8 plus 12 minus 10. So beta, this will come out as 10 plus 10, 4 upon 4 plus 2. So just solve this. You will get the answer as 16.67. So this is going to be the mod of your data set. Now, beta, whenever we use this formula to find the mode of the data set, we have some assumptions in the background. So please write down these assumptions. Assumption number 1. See, first of all, your frequency distribution, it must be continuous. So if my data is non-continuous, I must convert that into a continuous data set. Otherwise, I cannot find the mode. Just I gave you that example now for median also. So if your weights were say 93 to 97 and better than 98 to 102 and then 103 to 107 and so on, ऐसा कुछ था, you must convert this into a continuous data set. तो इसको आप लिखोगे 92.5 to 97.5, 97.5 to 102.5 and so on. If you don't convert this into a continuous data set, you cannot apply this formula. That's the first thing. Secondly, we need to make sure that our class intervals are uniform. So I cannot apply the formula if the class intervals are not uniform. Manik, see here. So the gap has to be 10 each now. The gap is the same. So I want that the width of the class should be the same. But beta, you cannot apply the formula of mode in a lot of cases. So there are 3 cases I would like to highlight in which you cannot apply the formula of this mode. First, if maximum frequency is repeated or approximately equal in 2 or more neighboring values. Yes, beta, it applies to median also, it applies to mean also. You can only go ahead and you can only do this if it is a continuous data set. Okay. Achha, now, so beta, if maximum frequency is repeated or approximately equal, so agar supposedly yahan par aisa hota कि बेटा ये भी 12 ही होता, then I cannot apply this formula. Why? खुद समझो. Because if बेटा this is also 12, then आपका ये जो gap है ना f1 minus f2 ये 0 हो रहा है. And we cannot apply this formula if we see this gap to be 0. That's one way to understand. The other thing is that suppose 12 yahan par bhi hota, then also there is an issue with it. So I just want to highlight that also. So the first is, if you see repeated frequency, then you cannot apply this formula. The second is, if you see maximum frequency in beginning or end. तो बेटा अगर मेरी मैक्सिमम फ्रीक्वेंसी सपोज यहां होती, सपोज ये 8 की जगह पे 18 होता, ये मैक्सिमम फ्रीक्वेंसी. सो अगर मैं इस क्लास को अपनी मॉडल क्लास अब मानूं, आई टेक दिस एज माय मॉडल क्लास, तो बेटा ये f1 हो जाएगा. इस क्लास में हाईएस्ट फ्रीक्वेंसी आ रही है, तो अगर f1 है तो f0 क्या होगा? What would be f0? What will be frequency of the previous class? Nothing. I don't have any preceding class. So how will I find this value? So I cannot apply this formula. Similarly, supposedly, let's say that your highest frequency is here. Suppose this is 22. Then this is your model class. Again, how will you apply it? How will you go further? What will be your F2 in this case? There is no class after this, na? So iski succeeding class kya hogi? Kuch bhi nahi. So you cannot apply this formula. So you cannot apply this formula whenever you have frequency, highest frequency in the beginning or the end. And third beta, you cannot apply this formula whenever there are irregularities. ये बहुत important point है. Irregularity का क्या मतलब होता है? See, regularity का मतलब होता है that once, so something like this. This is a regularized data set. Why? Because इस x की frequency इतनी, next x की frequency इतनी, next x की frequency इतनी. So the frequency of each x is first increasing and then decreasing. This is regularized data set. But beta, if I have a data set like this, कि इस x की frequency इतनी थी, next x की frequency बढ़ी, फिर वो कम हो गई, फिर वो वापस बढ़ी, फिर वो कम हो गई, फिर वो वापस बढ़ी. So if I have a data set which is like this, frequencies are increasing, decreasing, increasing, decreasing, then it is called as an irregular data set. And for those irregular data sets, you cannot go ahead and you cannot find the mode using this formula. So यहाँ देखो, 8 से 12, that means frequency increased. 12 से 10, frequency decreased. 10 से 8 decreased. 8 से 3 decreased. 3 से 2 decreased. So it first increased and then it decreased. This is a regular data set. But if it is irregular data set, then beta we use some other method, and that method is called the method of grouping. So now I want to go ahead and do one example where I will be using with you the method of grouping so that you are clear with that method also. Okay. So it can come in exam, yes. So, you know, any assumption, anything, for example, they can just ask that if your data set is irregular, which of the following technique would you use? You should be thorough with all kind of questions, beta. So yes. Okay. Now let us go ahead and take a question based on it. So what will I do? So I will have, I'm giving you the mode of the data set. So I'm giving you marks 0 to 10, 10 to 20, just write till 90. 20 to 30, 30 to 40, 40 to 50, 50 to 60. I don't want to leave anything from the point of view of exam. So, you know, make sure that you don't miss anything from what we do in the lectures. That's it. That is what is important. As I'm telling you, for each kind of topic, I will give you multiple examples of different types. हर example में एक unique चीज होगी जो दूसरे example में नहीं होगी. You have to do all those examples thoroughly for all the topics, whether it is probability distribution, hypothesis testing, maximum likelihood, कोई भी topic हो, जो example class में हो रहे हैं, you have to do those thoroughly. Now look at the data set beta. So this is going from 10 to 4. That means frequency is decreasing. Then it went from 2 to 18, frequency increasing. 18 to 22, frequency increasing. 22 to 21, frequency decreasing, 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 decreasing. So you have increasing and decreasing frequencies. It means it is an irregular data set. Since this is an irregular data set, we cannot go ahead and we cannot use the mode method, the direct mode method that we have been using. And therefore, we must go ahead and we must do this using the other technique. That means using the method of what I'm going to suggest, the method of grouping. So I should have first done, but just park this. Let me just do one question with you first, which is non-class. पहले एक example ना बिना class के कर लेते हैं. Then I will take this class example back. Just park this for now. Let me do a basic question with you on grouping first. So what I will do is, I will just give you some weights. And let's say I will give you some frequency. So I'm given the weight of the students. That goes 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and 60. These are the weights that you are given, and corresponding to weights, you're given frequency related to it. So 2, 4, 5, 6, 8, 5, 4, 7, 11, 5, and 3. As a data set. Again, it's an irregular data set. Why? Because you see the frequency goes from 2 to 4, increasing, 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 decreasing. अभी तक भी दिक्कत नहीं है. अगर एक बार increase हो के decrease हो, that is fine. Decreasing, but increased. Now it is an irregular data set. If it again increases, that is irregular data set. So now what I have to do is I have to start using the method of grouping. So beta, in order to do the method of grouping, look very carefully what you will do. You will go ahead and you will formulate multiple columns. So let me call this as column 1. I need to go ahead and I need to formulate 6 columns in total. So beta, this will be column 2, column 3, column 4, column 5, and column 6. अब देखो क्या करना है. Column बनाने के बाद, in the second column, you will add 2 numbers at a time. So मतलब you will add 2 and this together, 4 together, and you will get 6. And I will make a line here. Okay, beta. Then I will add these 2 together and I will get 11. Again, a line here. Right? And you will continue doing this. So when you will keep adding 2 together, you should get different numbers. So यहाँ पे एक बारी, let me draw this line also so that you can distinguish easily. So now you will add 8 and 5 together. So 8 and 5 will give you 13. Then you will add 7 and 4 together. That will give you 11. Then 11 and 5 together will give you 16. And beta last number के साथ कुछ add नहीं हो सकता. So you will keep it as it is. Now look at column number 3. In column number 3, what you will do? You will skip the first value. And you will do the same method, but you will start from this. So you will make a group of 2 each. And you will go ahead and you will add. So 4 and 5 together beta will give you 9. ठीक है? But किन दो को add किया ना वो ध्यान से mark करना है. So this is 9 from 4 to 5. Similarly, you will add 6 and 8 together. Similarly, you will get 14 here. So beta, this is here. Then you will add 5 and 4 together, you will get 9. So beta, make a line here. Then 11 and 7 together, you will get 18. So make a line here. And then beta 5 and 3 together, you will get 8. Make a line here. Right? Now, you will skip the first 2 and you will start from the third one. So if I skip the first 2 beta, third one क्या हो जाएगा? मतलब मेरे को यहाँ से add करना शुरू करना है. 5 plus 6 together is 11. 11 तो already यहाँ पे दिख ही रहा है इनके आगे. 8 plus 5 together is 13. 13 already दिख ही रहा है इनके आगे. So I don't want to do a duplication. ये वाले numbers already यहाँ पर दिख ही रहे हैं. जब मैं पहले 2 skip करती हूँ, I get back the original numbers only. So I should not be doing that. So now what I do is I start by adding first 3 numbers together. So what you will do is you will add 2, 4 and 5 together. So when you add them together beta, you will get 11. So now I will write 11 here, but I have to be very thorough with which numbers I'm getting 11. So 2, 4 and 5. So 5 ke corresponding mein I will draw a line. Then same, I will add 6, 8 and 5 together. So 6, 8 and 5 gives me 19. And I will draw a line here. Right? So if you do this, then this, and this. So 11 and 11 is 22. I will get a line here. And done. Same, you will skip the first one and you will start from the second one. So 4 plus 5 plus 6 together, you will add them together, and beta you will get 15. So leave the first one, and then you will get 15 with 4, 5, and 6. So I will have a line here. Then I will have 17. I will have a line here. And then I will have 23. I will have a line here. Finally, skip the first two and start from the third one. So 5 plus 6 plus 8, you will add them together. So I'm starting from 5. 5 plus 6 plus 8, that means 19. And I will have a line here. Then you will get 16. You will have a line here. And then you will get 19. You will have a line here. This is what grouping method is. It's a little tricky, but you should just try and understand what we are doing. I'm just trying to add the frequencies at different levels. Okay, beta. Now just try and think about it that, now I want to go ahead and I want to see in each column, what is the highest frequency? So start from the first column. In the first column, as you can see that the highest frequency is 11. So I will mark 11. In the second column, the highest frequency is 16. So I will mark 16. In the third column, the highest frequency is 18. So I will mark 18. In the fourth column, highest frequency is 22, then 23, and then I have highest frequency as 19. So I will go ahead and I will mark 19. Now, once you go ahead and you do this, you just have to see which is the number corresponding to these highest frequencies. So beta, let us start with the number 11. ये जो number 11 था, ये किसके corresponding था? 58 के. Then second में highest frequency क्या आई है? 16 आई है ना? 16 is corresponding to which number? That is why lines बहुत important है. 16 is corresponding to 58 and 59. Then comes 18. 18 is corresponding to 57 and 58. Then comes 22. 22 is corresponding to 56, 57, and 58. Then comes the next highest is 23. 23 is corresponding to 57, 58, and 59. And then comes 19. And beta 19 here is corresponding to 58, 59, 60. ऊपर वाले भी लिख लेना जो corresponding है. Now see, ये अलग अलग टाइम पे हाईएस्ट फ्रीक्वेंसीज रही हैं. इनमें जो हमारी कॉमन क्लास है बेटा, जो सबसे हाईएस्ट नंबर ऑफ टाइम्स आ रही है वो 58 है. 58 is coming in every one of these. In each one of these, right? So since the value 58 occurs maximum number of times, I can say that this is the mode. That this method, this is called as the grouping method. So in the grouping method, you go ahead and you group them. And after grouping them, beta, you check that which is the class which has occurred the highest number of time. Whichever class has occurred the highest number of time, that will be your median using the grouping class. So grouping कब use करनी है? When you have irregular data set. अब इसमें एक last चीज है जो थोड़ा सा एक आखिरी चीज समझ लो. It may come in the MCQs as theory also. देखो, suppose when you group them, और ग्रुप करके रियलाइज होता है कि दो क्लासेस आ रही हैं यहां पर भी जो सेम है. जैसे यहां पर इफ यू सी 58 का फ्रीक्वेंसी, 58 इज कमिंग 6 टाइम्स. सपोज बेटा ऐसा होता कि 59 भी 6 टाइम्स आ रहा होता एग्जैक्टली सेम टाइम्स, तो मेरा ग्रुपिंग मेथड भी फेल हो गया. सो व्हेन योर ग्रुपिंग मेथड आल्सो फेल्स, in case you are not able to use your grouping method also, then in that case, so please write down, when grouping method fails, दैट मीन्स यहां से भी आपको एक बाई मॉडल डेटा सेट मिल रहा है. यहाँ पे भी 2 क्लासेस हैं जिनकी हाईएस्ट फ्रीक्वेंसी है. I will give you an example. Then in that case, you can only use one thing, which is your empirical formula. That means that is mode is equal to 3 median minus 2 mean. बेटा बहुत सारे क्वेश्चंस में आपको मीडियन और मीन दिया होगा और मोड निकालना होगा. बट इसका कभी असली में यू शुड थिंक कि ये फॉर्मूला क्यों डिराइव हुआ. ये फॉर्मूला इसीलिए डिराइव हुआ क्योंकि बहुत टाइम हमारे पास जो डेटा सेट होता है वो बाई मॉडल डेटा सेट होता है. इट्स इल डिफाइंड. मतलब जो मोड है वो एक क्लास से ज्यादा में आ रहा होता है. सो इन दोज केसेस आइडियली that is when this formula was derived. That is where you should be using this formula. Let me quickly give you one example to it before we end the class. So better take this example. Suppose I give you a data set. X is given to you as 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. This is your X. And you're given frequency. So frequency is given as beta 8, 15, 20, 100, 98, 95, 90, 75, 50, and 30. Let's see if this is an irregular data set. तो बेटा यहाँ देखो, ये आपकी frequency बढ़ी, 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 कम हुई, कम हुई, कम हुई, कम हुई, कम हुई, कम हुई. So first of all, if I check whether this is an irregular data set or not, it is very clear that this is not an irregular data set. This is a regular data set. So ideally, you should be thinking that in that sense, ma'am, I should not be going ahead and using anything. And my answer should simply be 100. But if you go ahead and you give 13. 13 has the highest frequency now. So if you go ahead and give your answer as 13, it is fine. There is nothing wrong with it. But if you remember, I had given you the 3 cases where we cannot use mode, right? So according to a lot of books, you should not be directly saying that 13 is your mode. Why? Because it says if maximum frequency is repeated or approximately equal frequencies. So beta, because here I see that one class has a frequency of 100 and other has 98. They are very close to each other and others have just 8 or others have just 30. So there is a chance that even this can act as a mode, that even 14 can come as a mode. So when you have these frequencies very close to each other, a lot of the books go ahead and they say that you should be using grouping method. So what should you be doing in exam? According to me, even finding this 13 is fine. But you just should be very alert that suppose someone asks you, when will you use grouping method? You can use grouping method even, zaruri nahi hai, dono ka equal hona hi hai. Even when they're closely equal to each other, then multiple books will use grouping method. First of all, be clear. Now, beta, once this is done, what you can do is, in case I go with grouping method, I must go ahead and I must create these groups. So I will go ahead and I will create these other columns, column 2, 3, 4, 5, and 6. I will go ahead and create these columns. Then you will start adding them. So you will see that, okay, 8 plus 15 is 23. So I will write 23 here. And then you will keep making, you will keep doing these 2K gaps. So you will get 120 here, right? Then you will again add these together. So you will get 193 here. Then you will add these together. You will get 165 here. Then you will add these together. You will get 80 here. Sorry, beta, एक data में मेरे से गलत हो गया. This is 80 actually. So closed data set ये आ रहे हैं 98 and 95. These are closely related to each other. That is why we are going ahead and using the grouping method. So this should be 100 actually. Now you will add leaving the first one. So beta ये दो को add जब हम करेंगे, I will get 35. Then when I will add these two together, I will again get the data set. I will add these two together and keep doing this. Right? So you will go ahead and you will get 178. You will then add the next two together and you will get 185. Then you will add the next two together and you will get 125. Right? Then you will skip the first two and you will start from the third one. Right? So when you will start from the third one, you will keep getting the same data set. अगर मैं third से शुरू करूँ तो मुझे same ही आएगा. That means I should start by adding the first three together. So you will have 8 plus 15 plus 20. So when you will add these together, you will get 43. Then you will add the next three together. Then you will add the next three together. ऐसे करके just formulate this entire case. Now, once you do this, you will realize that those classes with the highest frequency, beta, you will get both 14 and 15. Just fill this table. You will see that both 14 and 15 correspond to the highest frequency. जब हम ये circles बनाएंगे, जैसे मैंने यहाँ पर ये circle बनाया, यहाँ पे ये बनाया circle, है ना? यहाँ पर ये circle बनाया. So you will realize that both 14 and 15, they are coming 4 times. Now, because that happens, it means that it must be a bi-model class. So when this will happen, when you will have a bi-model class, that is where you will calculate the median, you will calculate the mean, and then you will calculate the mode. And actually, if you go through this entire process, I will just give you a snip of my answer. You can have a look at that. If you go through this entire process, the mode that you will get in this case, beta, it is coming out as 14.82. So that means the mode is neither 14 nor 15, but the mode is coming in between 14 and 15. That is what the mode will come if you go via this big formula of 3 median minus 2 mean. So what have we learned today? This is important. Beta, we have learned that if you have a uni-model data set, then just do the usual formula of mode. If you have a data set which is uni-model but irregular, frequency is increasing, decreasing, increasing, decreasing, beta, that is when you will go ahead and use the grouping method. But if you have a bi-model data set, even after grouping method, group करने के बाद भी दो classes आ रही हैं with highest frequency, then you should be going with the empirical formula. This is very important to understand that how you will go through these three cases. Now, quickly, I will just tell you what to be done here. So, beta, when you have this data set given to you, यहाँ देखो कुछ नहीं है. Everything is the same. It's just that in this case, you are given class. Number की जगह class दी हुई है. But उससे क्या फर्क पड़ता है कि number की जगह class दी हुई है? I still have to do the same thing. That I see that the frequency is decreasing. Frequency is increasing, increasing, decreasing. It's an irregular data set now. So I will just go ahead and use my usual technique of grouping. So beta, this will be my first column and I will formulate 5 more columns. So 2, 3, 4, 5 and 6. I will just formulate those columns. And after formulating those columns, I will start adding. So this will become 6, this will become 40 and so on. When you will do this, you will get a data set. 6, 40, 40, 13. ऐसा एक data set मिल जाएगा. हर एक से you will find the highest frequency. Now, the only thing that will differ is कि जब हम यहाँ पे कर रहे थे, so हमें एक frequency ये मिल रहा था, x मिल रहा था. We were saying 58 is coming 6 times. So 58 is the mode. But यहाँ पे whatever will come the highest number of times, that will act as a modal class. So for example, in this case, if you see that this comes the highest number of times, ये यहाँ पर भी आ रहा है, फिर इसकी यहाँ पे भी highest frequency हो रही है, आगे भी हो रही है, then this will act as your modal class. Once you have identified the modal class, mode निकालना तो formula के through ही है. So we know that in that case, the mode will simply be L plus H, F1 minus F0 upon F1 minus F0 plus F2 minus F1. So the grouping method in this case, it is just going to help you to identify what is the modal class. पहले ग्रुपिंग मेथड हेल्प कर रहा था आइडेंटिफाई करने के लिए एग्जैक्टली व्हाट विल बी द मोड. जिस भी चीज की हाईएस्ट फ्रीक्वेंसी आ रही थी वो डायरेक्टली मोड बन रहा था. इट वाज बिकमिंग द मोड इन दिस केस. बट नाउ द ग्रुपिंग मेथड विल ओनली हेल्प मी आइडेंटिफाई द मॉडल क्लास एंड देन आई विल जस्ट पुट दैट इन दिस फॉर्मूला एंड आई विल फाइंड द मोड. ओके, सो टुडे आफ्टर यू गो बैक, after you start studying, I will give you some questions on this modal class. ये ज़्यादा important है that we understand what is mode using grouping method, and for different type of questions, I want you to practice all of those before you come for the next class. Okay, so I will give you some 5-6 questions on median and mode. Please practice those. Okay, thank you, beta. We can end the session for today. If there is any doubt, I can take that. When I talk about range, range is the gap between upper and lower limit. So let's say that I have a data set. And suppose I just go ahead and sort this data in ascending order. So, initially my data was 4, 8, 3, 2, 10. I sort it in the ascending order and I get 2, 3, 4, 8, 10. The upper limit of my data set is 10. The lower limit of my data set is 2. And the range is 8. So the highest minus the lowest value of the data set, that is called range of the data. It helps us to understand what's the variation in between, what's the highest most value and the lowest most value. The second thing that you should understand is called quartile deviation. Quartile deviation is half Q3 minus Q1. Now, in order to understand this, we must know what is Q3 and what is Q1. So just try and see here. Let's say I have this data set with me. I know that if I want to go to its middle value, this would be median. Median would be such that the 50% of the data set would be above this value and 50% of the data set would be below this value. Now, what is Q1? Q1 is such that if I go ahead and divide the data set, 1/4 of the data set would be above and 3/4 of the data set would be below. This value would be called as Q1. Similarly, what would be Q3? If I go ahead and I put a break here such that 3/4 is above and 1/4 is down, then it would be Q3. Now, if you would have remembered, the formula of median that we studied was L plus N by 2 minus CF upon F into H. This is the formula of median for class intervals. What I can do is, instead of writing N by 2, I can rewrite this as 2n by 4. I am imagining that my data set is divided in 4 parts. 1, 2, 3. These are the 4 parts of the data set. First, second, third, and fourth. This is my entire data set that I have. And median is exactly half of the data set. So it is 2 by 4. 2 portions here and 2 portions here. Then quartile 1 would be here. It would be where 1/4 is here and 3/4 is here. Which means I want to go ahead and divide my data set such that I take the first 1/4 of the observation. So for Q1, I will, instead of having 2 by 4, have here 1 by 4. If I write it like this, this is the formula for Q1. Similarly for Q3, instead of writing this as 1 by 4, I just have to write this as 3 by 4. Then the formula will change into the formula of Q3. So for Q2, it is 2 by 4. Q2 is nothing but the median. Second quartile. 2 above and 2 below. Q1 is 1 above and 3 below. Q3 is 3 above and 1 below. This is how you find quartiles. So in the most simple term, quartile is formulated from quarters. Quarter means dividing the data set in 4 parts. When you divide the data set in 4 parts, then the first part is called Q1. The first 3 parts, if I have that way, it's Q3. And now we define quartile deviation as the gap between Q3 and Q1 divided by 2. So quartile deviation is like the average gap between Q3 and Q1. You can rewrite this as average gap between Q3 and Q1. It's like saying, I found out what's the gap between Q3 and Q1. I am trying to go ahead and average that out. That will be quartile deviation. So many books define something which is known as decile deviation also. Or at least they define something which is known as decile. Very simple on very similar basis. I have a data set and I am dividing this data set in 10 parts. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 equal parts that I have. And now I'm saying, look, if I go ahead and take 5 portions here and take 5 portions here, this should be exactly half of my data set. I should have 5 portions here and 5 portions here. This is half of my data set. This half of the data set was called median. But if your data, instead of getting split in 2, is getting split in 4, then it becomes Q2. And if this data is getting split in 10, then this becomes D5, decile 5. 5 portions of the, data set on one side and 5 portions of your data set on the other side. Now you can again find out, if I ask you find D1, it means you are saying that I want 1/10 of the data here and I want the remaining 9/10 of the data here. So instead of 1 by 4, what will you have? You will have here 1 by 10 and this will be now D1. You can find D1, D2, D3, D4, D5, D7, D10, whatever you want, right? So if you ask me D9, I want 90% of the data set, 9 by 10. If you ask me D5, 5 by 10, but 5 by 10 will be n by 2. That's the formula of the median. So I can divide my data set in 10 parts and just change this part. And accordingly, I will get the value. Same goes with something called as percentile also. Just you can note all of this. I don't have these in my notes, but just make a note of this also. Percentile is dividing the data set in 100 parts. Again, the formula is the same. You can find P10, P90. P10 will be N into 10 by 100 here in the formula. So whatever N is getting multiplied with, if I'm finding P10, it means there are 100 parts. And I'm finding what is first 10 parts versus the 90. So 10 by 100. If you ask me to find P90, it will be 90 by 100. P50, 50 by 100. That will be median, N by 2. So you can divide your data set in just 2 parts using median. 4 parts, quartile. 10 parts, decile. 100 parts, percentile. Just write down here. You can have median. You can have quartile. You can have decile. You can have percentile. Okay. If you ask me quartile deviation, Q3 minus Q1 by 2. Decile deviation, 10.9 minus 10.1 by 2. Percentile deviation, P90 minus P10 by 2. You ask me, I will just give you the extreme value ranges, subtract that and divide that by 2. This is how you can go ahead and find these values. Deviation and variance of population, they are represented by sigma square or sigma. And that of a sample's standard deviation or variance, they are represented by S or S square. Unless, they specify in the question that this is population and this is variance. Sometimes most of the Indian authors especially will use them interchangeably. They will just say prove S square is summation X square by N, something like that. So they will use this S square and sigma square interchangeably in the Indian books. Unless it's a question of hypothesis testing, where sample and population are of use. But foreign authors will make sure that you see this difference. Now what happens if in exam they give you this S square? How will you judge whether it is a sample or a population if it is not mentioned in the question? Then just try to figure it out with the help of sample size. If your N is 10, 11, 12, small number up to 30, consider it as a sample. It's a small value, no? It cannot be the entire population. More than 30, consider it fine. Consider it like a population. Now here is the thing why I'm saying this. Imagine that, so sigma square, this is summation xi minus x bar whole square by n. And sample ka, it is summation xi minus x bar whole square by n minus 1. Now let me use capital N only to avoid confusion. Now imagine that my n is 100. Suppose. In this case, the sum that I'm getting is 1000. So one will be 1000 by 100 and the other will be 1000 by 99. For very large values of n, these will be very close to each other. You can find the value and check. They're very, very, very close to each other. This will be 9 point something, something, something. This will be exact 10. So because they are very close to each other, we assume that even when it would have been a sample and maybe I misunderstood it as a population, the final testing will work well. Nobody is asking me to find sigma square actually. They will ask me to do something with sigma square. So whether I take n or I take n minus 1, most of the time, 99% of the time, my t test, z test, f test will work fine. So for large enough size of n greater than 30, it is fine whether you use this formula or this. If you don't know, but if the question clearly mentions, take this sample, then you know, use this formula. If the question mentions, take this population, you know, use this formula. If they clearly give you sigma square, definitely population, right? If they give you S square, it's a good idea to take sample. But I am telling you, if your n is large enough and you solve with this formula, it is fine. That's all that we are discussing. Now let's just go back to this point. So I have to go ahead and I have to check what is my standard deviation. It will be summation x minus x bar whole square multiplied with the frequency divided by the size. No, it's mean, xi minus x bar, not assumed mean, the actual mean value that you have. Only that is why I said that if you don't take the absolute value, you will get the answer as 0. So it's the actual mean. So you can actually write this if you want to avoid confusion. A is the actual mean, x bar. Okay. Small n should technically come in S square formula, right? Why the big N? Achha, so ideally, when I talk about n is something which is very, very misrepresented. N just means the size of whatever observations I have. This n can be sample, it can be population. So many times I will show you, in fact, in the past year questions, they will say consider n is equal to 6. Now this cannot be my population. This has to be sample, but I will use capital N if it is given in the question. So the representation of n can always be questioned. If you feel that you have to go ahead and change between small and capital N, you can go ahead and take this as population and this as sample. It is only relevant to distinguish between population and sample if you do hypothesis testing. That's my last topic that I would be doing. When we do this, then it will make sense to distinguish between the two. Here in the formula, it will not make sense, but if you want to distinguish, you can say that, you know, this should be n minus 1 upon summation xi minus x bar whole square. Because if you start distinguishing that way, then you will realize that actually in population, mean is not written by x bar. Mean is written by mu. In sample, mean is written by x bar. So we have to start distinguishing between what is a parameter, what is a static. In दोनों में distinguish होना would be important. We are not doing that for now. So we are not deep diving into why यहाँ पर mu लिखना जरूरी है और यहाँ पे x bar, why small n and big N. We are just saying that if it is a sample variance, you will subtract 1 from the denominator. Otherwise, you will not subtract 1. And someone may ask why. Absolutely, we can use them interchangeably. One more thing. The question is why. Why the denominator will be n minus 1 and not n. This is because of something which is known as the degrees of freedom. Now, when we talk about the degree of freedom, in sample, we always have lesser degrees of freedom, which is n minus k. Let me give you an example. Suppose I tell you that the sum of 5 numbers is 20. Find these 5 numbers. What will you do? You will say, okay, I have to fill these 5 gaps and I want the sum to be 20. I can take the first number as 1 maybe, then I'll take 2, then I will take 3, then I will take 2. I see randomly I can pick any numbers. But I can only pick 4 numbers randomly. The 5th number is dependent on what the first 4 numbers are. This is not free to be chosen because I want the sum to be 20. So if this sum is 8, then I want that this number should be 12 if I want to go ahead and satisfy this. So how much is the freedom that you are giving me in this case? You're giving me the freedom to choose only 4 numbers. I cannot choose the 5th number on my own. So the degrees of freedom that I have is the number of numbers you want me to choose less 1. Now this is a very, very simple concept here. So just remember that when I talk about the degrees of freedom, the question is how free I am to choose things. And when I talk about the sample, I have 1 less degree of freedom because of the parametric value that I want to tend it to. I will talk about this in hypothesis testing. For now, only understanding the basic of it, that you're dividing by n-1 is enough. Okay, now let's just have a look at this question here. So just consider, I'm given the age group and I'm given the frequency. So I take the middle value of the age group for each of this. So 20 to 30, 25, 30 to 40, 35, 45, 55, and so on. Then I take one assumed mean. So this is my assumed mean. I subtract assumed mean. So 25 minus 55 will be minus 30. 35 minus 55 minus 20, and so on. I see that the common factor is 10. So I take H to be 10. And I also simultaneously divide by 10. So I get this as my final D. Minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now I just do F into D. So I get these values. And I do F into D square. And I get these values. So F into D. And then I am finding D square and multiplying F with that D squared. Mean formula we know from the last class. It is A bar plus H summation FD by N. So A is assumed mean 55. H is the gap 10. Then FD is minus 15. And the sum of the frequency is 542. I just put these values and I get 54.72. Always make sure that whatever assumed mean you're taking, it is the middle point. Aisa don't do ki ye assumed mean later. Answer will come, but you should always try to take the center point as the assumed. Now here is the formula for your sigma square. One formula what we did was this. Summation xi minus x bar whole square by n. Then I gave you another formula that you can write this as summation fi xi minus x bar whole square by summation fi. Now, if you go ahead and you are using the shortcut method of assumed mean, then you can also go ahead and use this formula. Very, very important. Okay. I want you to think in your mind. See, this is working on the deviations. Huh? I didn't take the value of A anywhere. So the question I'm asking is why there is no presence of assumed mean in this formula. Just think about this once. From assumed mean, I found deviation. Somewhere I should have used that assumed mean. I am using that assumed mean here to find the mean value. Why am I not using the assumed mean in this formula? How is this formula working absolutely correctly without the assumed mean value? I just want you to think through that once. So the formula is this. It says summation fd square by n minus 1 by n summation fd whole square into x square. Just take this into consideration once. See, when I find summation fd by n, and I'm multiplying this by h also, no? So suppose I open this up. Let's open this up once. What will we get? We'll get h square 1 by n summation fd square minus h by n summation fd whole square. Okay. Notice that this part, this is actually this part only. It is everything of the mean value except the assumed mean. So actually this part that I have here, this is nothing but x bar minus a whole square. Right? Now, from this, if you start solving this part, there is another very important relevant formula that you will get, that sigma square is summation xi square by n minus summation xi by n whole square, which is nothing but summation xi square by n minus mean whole square. This will also be your sigma square. So just notice here, I have deviations here. Deviation was nothing, but how did you define deviation? Deviation was this, right? Deviation was xi minus assumed mean by h. That was your deviation. So if you take back the value of your deviation here, your entire thing will be in xi's and a's. That a will get cancelled out with this a, and you will get your formula only in terms of xi's and x bar. Now, absolutely, you're very, very correct. Because of the change of origin does not matter. Correct. It's absolutely correct answer. Okay. So now just have a look here. I want to go ahead and define something which is known as expectation. I will do this a lot in probability, but just for now, I'll take complete class on expectation in stats. But just understand, expectation of any variable x is when you sum that and divide by n. मतलब mean निकालो किसी का तो वो उसकी expectation. Whenever you find mean of something, it's its expectation. So if I am adding all the xi square together and I am dividing by n, जहां पे भी you see this part together, ऊपर sum and नीचे n, you can rewrite that as expectation of xi square. So which means here also I'm finding this sum by n, here also I'm finding this sum by n. So sigma square can be rewritten as expectation of xi square minus expectation of xi whole square. This is the formula which comes in exam. Very, very important. You may mark this down. Most important. Throughout, we are going to go ahead and use this. So expectation of xi square, matlab you have a data of x, you find x ka square, and then you add all of these together and divide by n. And here you are first adding all of these together and dividing by n and then squaring it. This is this value. If you subtract the two, that is your sigma squared. So just come back here. I'm using this formula here to find sigma square. So summation fd square. Don't get confused between f into d square and fd whole square. This is first multiplying f with deviation, dividing it by n. Manet is finding the expectation of fd and squaring that. This is first squaring d square and then multiplying with f and then summing those over and dividing by n. So this is this part. Summation fd square. First finding d square, multiplying by frequency and adding that out. This is fd summed up. If you just put it in this formula, you will go ahead and get the answer.
Hi, good morning, everyone. So today we are going to go ahead and start our session with probability. Now, whenever we talk about the different kind of situations, we can go ahead and we can divide the situations in two main parts. The first is called as a deterministic phenomena. A deterministic phenomena is where you can go ahead and tell with certainty what will be the answer. Like for example, if I go ahead and I ask you what is the formula of velocity? What is the formula of force? Right? What is the formula of in economics, say GDP? There are certain formulas that we know कि ये यही होगा, V will be equal to U plus AT, right? Or force will be mass into acceleration. When we go ahead and when we have a certain formula with us, that is called as a deterministic phenomena. On the other hand, we can go ahead and have a non-deterministic phenomena, which is called as a probabilistic phenomena, which means that nothing will happen with certainty. For example, when we toss a coin, we can get head, we can get tail, right? There is a probability attached to head and tail. When the coin is in the air, I cannot tell you with certainty ki head aa raha hai ya tail, right? Both have equal probability of coming. So those phenomena which can have probability attached to them, they are called as probabilistic phenomena. And those where I know the answer for sure, that if you give me mass and acceleration, this will be the force, right? When I can go ahead and just put that thing in the formula, then that is basically going to be a deterministic phenomena. We are in our statistics throughout interested in the probabilistic phenomena. Now let us go ahead and talk about two things. One is called as a trial and other is called as an event. A trial is the experiment which you are conducting. Like for example, I am going ahead and conducting a trial of going ahead and tossing a coin. Right? An event, also called as an outcome. An event or outcome is the result of that trial, right? So when I toss a coin, I can either get head or I can get tail. So this outcome that I see, that becomes the event, right? So trial is the experiment that you conduct, like tossing a coin. The outcome which you go ahead and you see, that becomes an event. Similarly, here throwing a dice can be a trial. But what numbers you will get when you throw a dice, 1, 2, 3, 4, 5, or 6, those are basically the outcomes of your trial or the events of your trial. There is something which is known as exhaustive events. exhaust. Exhaust means taking the entire sample space. So when we say exhaustive events, it means that we are going ahead and we are talking about the total number of possible outcomes. Just for example, if I say when I toss a coin, I get head or tails. So head and tails together, they exhaust the entire space. There is no third thing that can happen. Ya head aayega ya tail aayega. So these are exhaustive events. They exhaust the entire space. Similarly, suppose I tell you that I toss 2 coins, right? So when I toss 2 coins, I can either get head, 2 heads, 2 tails, first head, second tail, first tail, second head. These 4 events together, they exhaust the entire sample space. There is no fifth thing that can take place. So this together, they exhaust the space. Yehi 4 cheezein ho sakti hain. So together they will be called as exhaustive events. So what is an exhaustive event? The total outcomes, right, that we have whenever we do something, do an event, whatever total outcomes we can have, that will be called as exhaustive events. Yes, sample space is total number of outcomes. Absolutely. Total outcomes is nothing but the sample space. Now you have mutually exclusive events. 2 events are said to be mutually exclusive if they have nothing in common. They have nothing in common. They exclude each other. Unme kuch bhi common nahi hai. So for example, if you look at the set theory, right, you would have heard things like A union B, A intersection B. What are these things? So if I take 2 set A and set B, right, then whatever is the common part between A and B, that is called as A intersection B. This is common between A and B. And what is A union B? When I take all elements of A and all elements of B. So when we talk about A union B, it means that I am going ahead and taking all of this and all of this. So A intersection B is what is common between A and B. Now, when we talk about mutually exclusive events, it means that they have nothing in common. So when they have nothing in common, it means that this is my A and this is B. There is no commonality, no intersection. Or A intersection B is phi, it is 0. There is no common thing between A and B. So when there is nothing common between A and B, then they are called as mutually exclusive event. They exclude each other. Jaise yahan par, if I go ahead and I say that event A is getting 2 heads and event B is getting 2 tails. So event A is HH, event B is TT. They have nothing in common, right? Then we can go ahead and say that they are exclusive of each other. But if I go ahead and I label it like this, that event A is at least 1 head, right? And event B is at most 1 head. When you toss 2 coins, you get at least 1 head and B है maximum one head. So at least one head means what? One या two heads. So either it will include events which have one head or which have two heads. And at most one head means what? Maximum one head. Mane no head or one head. So now if I try to find the common between the two, I can see that there are common events between the two, right? So we can go ahead and we can say that, yes, there is commonality between the two. I think, but no. So there are certain formulas to get A union B. You should be aware that A plus B minus A intersection B is A union B. The number of elements in A plus B minus A intersection B is A union B. This is the relation between A, B, A union B and A intersection B. Okay. So yes, so here they are not mutually exclusive. They have something in common, so they will not be exclusive of each other. Now, here the next thing is where we talk about favorable events. Favorable events is when we want to talk about the probability of the event which interests us. So for example, if I tell you find the probability that it will rain, it means that my favorable event is raining. So जिसका भी मुझे probability निकालना है, that will be called as my favorable event. For example, if I tell you find probability of getting two heads when a coin is tossed, again, favorable event will be the probability of getting two heads. So favorable means nothing, but what interests you? आप किस चीज में interested हो, क्या निकालना चाहते हो, that becomes your favorable event. Then we have something which is called as equally likely events. Equally likely events are those events which have equal probability of occurrence. So when probability of event A and B is equal to each other, then A and B are called equally likely events. Just for example, if I tell you A is getting head when a coin is tossed and B is getting tail when a coin is tossed. So probability of A is half and probability of B is also half. So A and B can be called as equally likely events. Similarly, when you throw a dice, the probability of getting 1, 2, 3, 4, 5, 6, this is all equal to each other and it is equal to 1 by 6. So these are all equally likely events. The probability should be equal in this case. Favorable events is nothing but what you're interested in finding. So for example, if I tell you find probability of head when coin is tossed, तो जो निकालना है head का probability निकालना है, so my favorable event will be getting head. So whatever you need to find, that will be called as favorable event. Now we have the concept of independent events. Independent events are those events which are not affected by other events. Take an example. Just I tell you that event A is getting head when coin is tossed. And event B is getting number 6 when a dice is thrown. So will event A affect event B? क्या A में head आए या tails आए उससे फर्क पड़ेगा कि dice में क्या आ रहा है? नहीं, right? So occurrence of A will not affect B. Whether you actually get head here या tails here, what outcome you will get when a coin is tossed will not affect the outcome you will get when a dice is tossed. दोनों अलग चीजें हैं, एक से दूसरे को फर्क नहीं पड़ेगा. One will not be affected by the other. So we can go ahead and say that these are independent events. Occurrence of event A is not affecting occurrence of event B. But suppose I go ahead and I tell you that A is whether it will rain or not. And B is whether you will go to college or not. Then A is affected by B, right? Or sorry, B is affected by A. Your going to college will be affected by whether it is raining or not. There can be some relation that if it rains, you will not go to college. So these can be dependent events. Okay. So independent events are those events. I will do its formula afterwards when we do conditional probability. Abhi nahi karna hai. But just understand this thing. Independent events are those events in which occurrence of one does not affect occurrence of other. एक के होने से दूसरे को फर्क नहीं पड़ता है. The two things are very different from each other. Mutually exclusive and independent events are different. You can write here the formula, but I will explain separately sometime in the next class. When we talk about mutually exclusive event, it means they have nothing in common. उनमें कुछ भी common नहीं है. So A and B के बीच में जो common part है, that should be 0. There should be nothing common between A and B. Probability of A intersection B is 0. Nothing common. But when we talk about independent events, then probability of A intersection B will be A into B, which I will explain later why. So the two things are different from each other. दोनों same चीजें नहीं है, right? So when we talk about mutually exclusive events, it means that they have nothing in common. उनमें कुछ common नहीं है, right? But when I talk about independent events, it means when one is occurring, other is not getting affected, right? If I am going for a movie, I am not affected by your choices of movie, right? वो independent है. मेरा decision is not affected by yours. So independent means occurrence of one event. एक event के होने से दूसरे को फर्क नहीं पड़ता, not affecting other event. But mutually exclusive means that two events don't have anything in common. उनमें कुछ common नहीं है. Two things are different from each other. Yes, that is absolutely correct. Independent events can have different sample spaces, but this will be part of the same sample space. Correct. Okay. Okay. So, for example, getting head in tossing second time is independent of the first toss. So, you took a coin, आपने उसे toss किया. You can get head or tail. But when you will toss this coin again, तो उससे उस coin को ये थोड़ी फर्क पड़ा कि what came in the first time. Whether the first time was head or tails. That is not going to impact what will happen the second time. In the second time, coin will give you an independent result, right? So same happens when you play snake and ladder. Just because you got 6 first time doesn't mean you will get 6 second time. The second time when you will throw a dice, the result will be independent. कुछ भी आ सकता है second time में. Whatever happened the first time, उससे फर्क नहीं, right? So when we talk about independent events, occurrence of the first event of one event is not affecting the second event. उससे दूसरे event को कोई फर्क नहीं पड़ेगा. It will not affect the second event. Now we talk about the definition of probability. So probability is the favorable number of cases divided by the exhaustive number of cases. Let us take a very simple example. So when I toss 2 coins, what are the outcomes I can get? या दोनों head हो जाएंगे, first head, second tail, first tail, second head, or both tails. This will be my sample space. Now, my probability जो मेरे को निकालना है, what I want to find out, find probability of getting at least one head. So what are my favorable events? One head. Where do I see at least one head? Here, here, and here. Here I see 2 head. So because question is saying at least one head, meaning either one head or 2 head. So I will see it here, here, and here. So what will I get? Head, head, tail, head, head, tail. Now, how do I define probability? Probability is favorable events upon total events. So what are my favorable events? 1, 2, 3. What are my total events? 1, 2, 3, 4. So probability will be 0.75. So when we talk about probability, it will be favorable events by total number of events. Let's look at some of the questions now. So look here. 2 unbiased dice are thrown. Find the probability that both dice will show the same number. So we are going to make one dice matrix, which is very useful in a lot of questions. So when you throw 2 dice, पहले dice पे it can give you 1, दूसरे dice पे भी 1 आ सकता है. First dice can give you 1, second dice can give you 2, first can give you 1, second can give you 3, first can give you 4, 1, second can give you 4, first can give you 5, 1, 5, 1, 6. And like this, you can just go ahead and you can just cover this up. So first dice can give you 2, second can give you 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 5, 1, 6, 1, 4, 2, 5, 2, 6, 2. With time, you should be able to do these questions without making this complete thing. This is only for the first time that I am making this for you. बिना ये बनाए एग्जाम में you should be able to do these thoroughly. 6, 3, 6, 4, 6, 5, 6, 6. Now just look here. Both dice show the same number. It means that this is 1, 1, this, and this. So if I look at these, here both dice are showing the same number, right? So how many such outcomes are there? There are 6 such outcomes. What are the total number of outcomes I have? 36. देखो, यहाँ पे 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 into 6, 36 total outcomes are there. So 6 by 36 will be the first answer. Now here I just want to focus on one thing, which I will be just talking about it. And I will be doing it in the coming questions. So here notice that कितने face and dice के a dice is 6 faced. मतलब 6 digits आते हैं उस पे 1, 2, 3, 4, 5, 6. So when a dice is a 6-faced dice, so the total number of outcomes that you are getting, they are 6 to the power 2, that means 36 outcomes. This means that when a dice will be n-faced dice, n तक extend कर रहा है. I'm making a general case. So I'm not saying कि इसके सिर्फ 6 faces हैं. It is a n faced dice. So what will be the total number of outcomes? N square outcomes. Okay. Now you can just try. If I put n equal to 6, so I will get 6 square outcomes. माने अगर इस डाइस के 7 फेसेस होते, हाँ, नंबर 7 तक आ सकता था. If I could have got numbers till 7, right? Then I would have got 7,1, 7,2, 7,3, 7,4, 7,5. 7 would have been included, 7,6, और यहाँ पे आ जाता 7,7. And here I would have had 1,7, 2,7, 3,7, 4,7, 5,7, 6,7. So if you would have seen, you would have had 49 outcomes. है ना? So whenever a dice will be thrown twice, अभी हम twice का ही बात कर रहे हैं. We are talking everything about throwing it twice. So if a dice is thrown twice, then if there are n faces of the dice, there will be n square outcomes. So in exam, if they tell you कि जो dice है, it is 8-faced dice and it is thrown twice, so 8 to the power 2. 9-faced dice, 9 to the power 2. But to the power 2 क्यों? Because I am throwing it twice, right? So that is why to the power 2. Now here just try to think about the next one. So it is saying first dice shows 6. Second can show anything. The first dice should show 6. That means that I am here. The first dice should show 6. Second say I am not interested. First one should show 6. So what will be the probability of this? There are 6 such outcomes. So I will have 6 divided by 36. And that will be the answer. Now the next one goes ahead and says the total number on dice is 8. So I want that the total sum should be 8. So just try to see here. 6 plus 2 is 8. 5 plus 3 is also 8. 4 plus 4 is also 8. 3 plus 5 is also 8. And 2 plus 6 is also 8. So if I look here, there are 5 such outcomes which give me the sum as 8. So I will get the answer as 5 by 36. The answer will be 5 by 36. Good evening everyone. बेटा आज हम सबसे पहले we'll go ahead and we'll study the axioms of probability. हम probability axioms के बारे में बात करेंगे और इसमें सबसे पहला axiom जो आता है वो ये है that probability of any event is greater than equal to 0. माने किसी भी चीज का probability negative नहीं हो सकता है, right? It is always non-negative. It cannot be negative. But axiom number 2 that the probability of sample space is 1. The probability of sample space is 1. माने जो भी मेरा sample space है अगर मैं वो सारी चीजें include कर लूं, then the probability will be 1. For example, but when you toss a coin, तो what can be the possible things? क्या क्या हो सकता है? या head होगा या tail. Now, if I ask you what is the probability of head or tail, तो आप बोलोगे, ma'am, you have included both the events in the sample space. My sample space only had 2 events, either head or tail. And you have included both. You are asking probability of head or tail. So because you have included both the events, ma'am, therefore we can say that this will be 1. Probability of head or tail will be 1. So the probability of the sample space is 1. ठीक है, तीसरा बेटा. When we have A1, A2 till AN as disjoint events. Disjoint events माने इनमें कुछ भी common नहीं है. बेटा अगर common नहीं है तो एक बात बताओ मुझे. There is a rule कि A union B equal to A plus B माइनस A इंटरसेक्शन B. ये रूल है. A union B equal to A plus B minus A intersection B from set theory. But if I put probability everywhere, तो probability of A plus probability of B minus A intersection B हो जाएगा. Now, बेटा disjoint का माने होता है, what is the meaning of disjoint events? Disjoint events means that A and B have nothing in common. A and B have nothing in common. तो अगर A और B में कुछ भी common नहीं है, then बेटा A intersection B will be 5. Null set. A और B में कुछ भी common नहीं है. So A intersection B will be 5. तो probability of A intersection B will become 0. The probability A union B will become probability of A plus B. It will become probability of A plus probability of B. Up, suppose we have many events A1, A2 till AN. So beta probability A1 union A2 so on till AN. Whenever they are disjoint, तो disjoint में हमने क्या किया? We added the probability of events together. So this will be summation probability AI, I from 1 to n. Summation probability AI, I from 1 to n. माने they have nothing in common. तो if I have to represent them, ये A1 हो गया, ये A2 हो गया, ये A3 हो गया, ये A4, ये A5. They have nothing in common, right? These are disjoint events that we have here. ये बात समझ में आती है? Is it clear? So these are the axioms of probability that you have. Okay, beta. Proposition. बेटा whenever something is a null set माने उसमें कोई भी एलिमेंट नहीं है, then probability of null set will be 0. अगर उसमें कोई एलिमेंट ही नहीं है तो उसके होने का probability भी तो 0 होगा. If there is no element in anything, then the probability of it happening should be 0 only, na? So if it is a null set, then the probability of anything happening will be 0. ये बात समझ में आती है? Right? Is it clear, beta? Okay. So now, if I ask you, what is null intersection null? What is null intersection null? Of course, it has to be null. Null intersection null भी तो null ही होगा. By there is a set which has nothing. There is another set which has nothing. तो both set together will also have nothing. है ना? तो बेटा, suppose if I tell you that set A1 is null, set A2 is null, the probability of A1 will be 0. Probability of A2 is also 0. The probability of A1 union A2 will also be 0, na? Probability of A1 union A2 will also be 0. ये बात समझ में आई? Is it clear, beta? Okay. Now, let us go ahead and let us talk about another important aspect, huh? And that aspect is related to, write down, suppose A1, A2 till AK are disjoint events. ये past year question say question I'm telling you. Then can you prove A1 union A2 union AK is summation I from 1 to K probability AI. अब बेटा A1 से AK तक they are disjoint events. If they are disjoint, it means intersection is, individual intersections are 0. It's like this. ये A1, ये A2, ये A3. They have nothing in common. So if intersections are 0, then the union will simply be the sum. Union will simply be the sum. Is it clear? हाँ, ये clear हुई बात? Okay. Now, I want to go ahead and I want to talk about counting techniques. Let's say that What is the probability of any event A? Probability of any event A can be told as number of observations in that event A by total number of observations. So this will be number of outcomes in event A by total number of outcomes in sample space. You remember we did probability का basic definition class 11-12 में. What was probability? Number of favorable events divided by total number of events. बेटा ये favorable events ही अब ये हो गया है. Because getting A is favorable and total number of events ही हो गया. Right? Is it clear? This is called as counting technique. Okay. Now, if we understand what counting technique is, so something which is very important in your probability, that is permutation and combination. Permutation is used whenever you have to have ordered set. माने order important है. And combination is used whenever you are doing selection but without order. Selection but without order. वहां पे unordered जहां पे है वहां पे आपको combination use करना है. But before that, I want to tell you what is factorial. So if I say n factorial will be beta n into n minus 1 into n minus 2 and so on into 2 into 1. Beta 1 factorial is 1. 0 factorial is also 1. अब अगर I say npk, माने if I am applying permutation, then this can be written as the following. It can be written as, so npk will be n factorial upon n minus k factorial. And if I have to write nck, माने अगर मुझे कहीं combination use करना है, so it will be n factorial upon k factorial n minus k factorial. ठीक है? That is the difference between permutation and combination. अच्छा, do you notice कि अगर मैं if I just multiply and divide by k factorial, तो ये वाला जो part है ये combination बन गया. This is combination, isn't it? So can I say that npk permutation is nothing but nck into k factorial? Isn't it? ऐसे भी बोल सकते हैं. Permutation is nothing but nck into k factorial. हाँ, ठीक है बेटा. Let us try to go ahead and let us try to take one question, right? And this is from your past year exam. So write down how many 5-letter words can be made out of, how many 5-letter words can be made out of 26 letters of the English alphabet if repetitions are allowed but not consecutive repetitions. If repetitions are allowed but not consecutive repetitions. इसका क्या मतलब है? What does this mean बेटा? It means कि आप A को 2 बार ही तो लिख सकते हो. A, B, C, A, D ये allowed है. But A, B, C, D, this is not allowed. A cannot come consecutively. A can come twice, A can come here also. ऐसा भी हो सकता है कि A, B, A, C, D. Yeah, A, B, A, C, A. It should not come consecutively. That is what we want to go ahead and we want to tell. Okay. That is what the question is going ahead and asking us. Acha, now let us go ahead and place 5 positions. 1, 2, 3, 4, 5. Okay. Now, beta, please try to understand that when I have to make a 5-letter word, जब मुझे 5 letter का word बनाना है, then if one word alphabet comes here, that alphabet cannot come here. वो alphabet यहाँ नहीं आ सकता है. It can come anywhere. Oh, sorry. It can come anywhere, but not in the just subsequent position. वो possible नहीं हो पाएगा, right? So if I have any 26 alphabets coming here, A, B, C से लेके Z तक कुछ भी आए, whatever alphabet comes here cannot come here. So I can have any 25 alphabets coming here, but not that alphabet because consecutive repetition is not allowed. ठीक है. अब suppose यहाँ पे A है और यहाँ पे B आ गया. ठीक है. Here any of the remaining 25 can come except B. B के अलावा कुछ भी आ सकता है. ठीक है. Suppose यहाँ पे वापस A आया. Here again any of the alphabets can come but not A. Any of the 25 alphabets can come. Any alphabet. Suppose यहाँ C आ गया. Then here any of the alphabets can come except C. Any of the 25 alphabets can come. Okay. So you have 26 into 25 into 25 into 25 into 25 in which these alphabets can be repeated. In which these alphabets can be repeated. Right. So how many can? So what is the answer that we have gone ahead and we have got beta? 26 into 25 to the power 4. 26 into 25 to the power 4. Is this clear? Clear ho gayi baat? Okay, beta. We'll stop the lecture here today. Thank you.